Okay, good morning to everybody, to all of you that are online and that are physically here, physically less, but I hope that in online we are growing in the numbers. Today we will have our industry and project day, so I hope that after this first 2 days you will be interested also in this thematic day. So we start with the open innovation challenges with our colleague from CEI Valencia, Carmen, who will present you about the concept from open innovation, how to connect the open innovation with the blue energy technology development, and she will show you the open innovation challenges that are put in front from our partners. So, Carmen, please take over.
Hello, good morning. Good morning, everyone. I am going to introduce the Open Innovation Challenge from Blue Deal Project. Okay, so I am sharing my screen. Great. Okay, then, well, hello. So I am going to begin this presentation. And I have to say that we are really delighted with this initiative because it allows to link many entities related to blue energy, which otherwise find difficult to connect. Okay, so this is an opportunity for the companies and entities working with blue energy. Okay, so before we see the concrete challenges, let's talk about open innovation and its meaning. Okay. So the term open innovation means a situation where an organization doesn't just rely on their own internal knowledge for innovation, but also uses external sources to drive innovation. Open innovation, we can say that it's a great way to access diverse sources of new perspectives and ways of thinking. By working with external partners, you will be able to increase your chances to improve your innovation efforts. Okay, so in this context of open innovation, the most established companies or entities will interact with the entrepreneurial ecosystem and their researchers and advance their challenges. Okay, so what we have done in this initiative with the Open Innovation Challenge, we have offered organizations the opportunity to launch a challenge to search for innovative product, process, and services solutions that are most in line with their needs. Launching a challenge allows the company to take advantage of the innovative potential of startups and businesses to drive and implement their business innovation processes. In return, they offer expertise, budget, and a market for startups. Okay, so we have prepared a video to explain how we want to improve and how we want to develop these open innovation challenges. So let me share it with you.
In an increasingly interconnected world, it is vital that companies and organizations find a way of cooperating to carry out research, innovation, and development projects. How can this be achieved? Through open innovation. But what is open innovation? Open innovation is a strategy under which organizations go beyond their boundaries, where cooperation with external professionals and clients is central in the development of high-impact projects. Open innovation exists when an organization does not just rely on their own internal knowledge, sources, and resources to drive innovation, but uses and includes multiple external sources as well. In the Blue Deal project, we seek to facilitate the creation of links and synergies between companies, researchers, entities, and public authorities in order to promote research, innovation, and investment in marine renewable energy in the Mediterranean. So, in the context of promoting innovation, we are launching this Open Innovation Challenge, where established companies or entities will propose challenges and interact with the entrepreneurial ecosystem and researchers to find innovative solutions which will support the further development of marine renewable energy. The Blue Deal Open Innovation Challenge will promote the efficient matching of demand and supply of innovation and knowledge-based services in the blue energy sector. Who can participate? Challengers and solvers. If you have a need or innovation challenge related to blue energy, send us your challenge so it can be matched with innovative solutions. Or, if you have an innovative solution to the challenges proposed, submit it for the opportunity to solve the challenge. Through participation in the Blue Deal Open Innovation Challenge, you will be able to connect with other innovative organizations in the sector. Do you accept our challenge? Let's make a Blue Deal. More information on our website.
Okay, so now that we know what is open innovation, and we have to say that we are working with this from months ago, and we have collected all the challenges, okay? We are 12 partners in the project, and we have 12 challenges, okay? And they come from the 6 countries of the project: Spain, Italy, Greece, Cyprus, Albania, and Croatia, okay? So we have all these challenges, and the challengers we have municipalities from Iceland and from the land, 1 county, we have companies, a port and a marina, and a national energy center, and also a federation of municipalities. So as you can see, we have different challengers, we are working with them, okay? So what are these challenges about? As a summary, although now we will see them in detail, we can say that we have different challenges, okay? So we have islands looking for sea energies to get clean power and ensure the energy security. We have also a big city wanting to test different blue energy technologies. We have ports and marinas looking for blue energy technologies to be installed and tested in their areas. We have companies looking for specific improvements of their developed technologies. We have public authorities worried about training and jobs in this blue economy sector. And we have municipalities looking for a defined local governance model to decarbonization based on the BA production, okay? So we see that many of the issues related to the blue energy are represented. We are going to see now in more detail some of the challenges. We have prepared a video describing each one of the challenges. We have 8 videos ready, and we are going to share them with you. We would like to do it in parts, let's say, but due to the connection, it's better if we put all the videos together. So now you are going to see the 8 videos from 8 partners, okay? And then later we will explain them. Each one of the challenge we will explain, okay? The 12 challenge. So these are the challenge.
Sono Sergio Ortelli, sindaco dell'isola del Giglio, la seconda isola per grandezza dell'arcipelago toscano. Dopo l'ottima esperienza maturata con il progetto Maestrale, abbiamo deciso di aderire all'iniziativa del Blue Deal, ovvero dello sfruttamento delle Blue Energy qui a Giglio Porto. Il fabbisogno energetico dell'isola è costituito dalla produzione termoelettrica. Lo sfruttamento delle energie marine rinnovabili può rappresentare una grande opportunità per trasformare l'isola in un territorio autonomo dal punto di vista energetico. Per tale motivo siamo alla ricerca di esperti del settore in grado di fornire soluzioni progettuali innovative che rendano possibile l'inquadramento paesaggistico delle tecnologie Blue Energy nel contesto del Giglio.
Salve, sono Giuseppe Schiboni, sindaco del comune di San Felice Circeo. Siamo nel cuore del Parco Nazionale del Circeo, una cittadina sempre attenta alle problematiche ambientali. La nostra città, infatti, è bandiera blu da più di 10 anni. Abbiamo aderito al progetto Interreg Med Blue Deal per produrre energia elettrica dal mare e rendere la nostra città più ecosostenibile. I nostri principali obiettivi sono la riqualificazione del litorale cittadino, l'illuminazione pubblica e la mobilità sostenibile. Vogliamo integrare la nostra infrastruttura di ricarica dei mezzi elettrici con un impianto alimentato dall'energia del moto ondoso. Invitiamo sviluppatori ed esperti a proporre una soluzione che sfrutti il fronte offerto dai moli del porto e dalle barriere frangiflutti già esistenti. Promuovere la mobilità sostenibile è il nostro contributo alla transizione energetica.
Hello from Split. My name is Martin Buchan and I'm Senior Advisor at the Department of Economy, Youth Funds and Agriculture of Split-Dalmatia County, one of associate partner of Interreg Med project Blue Deal. In our county, there is ongoing strong reorientation from the traditional fishery and shipbuilding industry toward the service sector, mainly tourism. Nevertheless, this transition will result in an inevitable loss of knowledge and skills that workforce has created during the decades of industrial activities. Therefore, the industrial transition should also be oriented on training and preparation of the workforce for the novel, innovative technology, especially related to the maritime business. Marine, renewable energy sector, especially blue energy conversion technology, are facing challenges to reach commercial scale of application, while the workforce requalification offers a sustainable pathway that overcomes current obstacles. This would help preserve the know-how collected during the years, but moreover, it would open new niche and potential for further industrial development and the creation of high-income jobs. We are looking for consultants, governmental bodies, entities working in the field of vocational training, and enterprises that already restructured their workforce to provide guidelines, measure, or courses which would boost the traditional process and result in the successful implementation of requalification and training programs.
Γεια σας, ονομάζομαι Δημήτρης Βλαχοκυριάκος, είμαι ιχθυολόγος και δουλεύω στις μία από τις 6 μονάδες πάχυνσης της εταιρείας Levantina Fish. Η εταιρεία μας παράγει ετησίως γύρω στους 5.000 τόνους, από τους οποίους το μεγαλύτερο ποσοστό εξάγεται σε 17 χώρες σε όλο τον κόσμο. Εδώ, ανοιχτά στον κόλπο της Λεμεσού, βρίσκονται οι 2 από τις 6 μονάδες πάχυνσης. Η ενέργεια που απαιτείται για τη λειτουργία των μονάδων παράγεται από ηλεκτρογεννήτριες, οι οποίες καταναλώνουν ετησίως γύρω στους 25 τόνους πετρέλαιο. Στοχεύουμε στη μείωση των εκπομπών ρήπων των μονάδων μας και επειδή βρισκόμαστε εδώ ανοιχτά στη θάλασσα, θα θέλαμε να χρησιμοποιήσουμε αυτή την γαλάζια ενέργεια που υπάρχει γύρω μας, έτσι ώστε να εναρμονιστούμε και εμείς πλήρως με το περιβάλλον που μας φιλοξενεί εδώ καθημερινά.
Soy Pedro Mayorga, fundador y director técnico de Enerocean. Enerocean es una empresa dedicada al estudio y a la explotación de las energías marinas. Aunque las energías marinas son una de las formas de producción de energía con menor impacto ambiental, estamos buscando la mejor solución para mejorar la visibilidad y la posibilidad de detección de la presencia de estos dispositivos en el mar, de forma que sea más aceptado por la población y tenga menor impacto visual. Nos gustaría oír vuestras soluciones para utilizar tanto los puntos de las turbinas como las boyas que marcan la zona del parque para aumentar la visibilidad y seguir cumpliendo todos los requisitos legislativos de este marcado. Por favor, mándanos tu solución.
Buongiorno, sono Bruno Santori, direttore della Marina di Pescara, la società che si occupa della gestione di uno dei maggiori porti turistici italiani. Abbiamo aderito al progetto Interreg Cost Energy e partecipiamo all'iniziativa Interreg Med Blue Deal per valutare l'impiego di fonti energetiche dai nuovi moli. La Marina di Pescara assorbe energia elettrica dalla rete elettrica nazionale ed utilizza gas naturale. Inoltre, e più in generale, il nuovo piano regolatore portuale prevede un ampliamento delle attività e dei servizi. Siamo orientati a realizzare una transizione energetica verso le rinnovabili e le energie marine rappresentano per noi un'opportunità emblematica. Tuttavia, le tecnologie disponibili in questo ambito al momento non sembrano essere mature ed affidabili. Vogliamo testare sistemi per generare energia elettrica dal motondoso per il nuovo piano portuale e selezionare le migliori tecnologie. Stiamo cercando imprese ed esperti in grado di fornire soluzioni tecniche, componenti meccaniche, turbine e generatori per trasformare il motondoso in energia e alimentare anche il Marina di Pescara.
Desde el puerto de Sevilla, soy Teresa Muela, la secretaria general de la Federación Andaluza de Municipios y Provincias, la entidad que representa a la totalidad de los ayuntamientos de nuestra comunidad autónoma y que tiene como misión la preservación de la autonomía municipal y la defensa de los intereses locales. El proyecto Blue Deal nos ha traído a la luz una debilidad que tenemos que convertir en una fortaleza, y es el hecho de no encontrar estructuras de gobernanza multinivel que hagan posibles hacer realidad la estrategia europea de energías marinas. La Agencia Andaluza de la Energía cifra en torno a el 24% del potencial de energía marina para nuestra tierra, del cómputo global de España. Tenemos más de 1000 kilómetros de litoral y necesitamos imperiosamente buscar las estructuras que nos hagan posible generar todo ese proceso de gobernanza multinivel. Nuestro reto, la modelización de la gobernanza multinivel para el aprovechamiento de la energía marina. Únete a ese reto. Vamos a identificar a los actores, vamos a conocer también los diferentes modos en los que van a interactuar y sobre todo vamos a conseguir con ello diseñar un modelo óptimo que permita no solamente producir, sino también rentabilizar esa energía marina que va a estar disponible para todos y para todas.
Okay, so I hope you like these challenges. Let me describe them more deeply. Okay, and we are going to, and we have seen 8 of the challenges, and now we are going to explain a little bit all the 12 challenges. Okay, so we are going to begin with the first. The first challenge belongs to the University of Siena, the project promoter, and will take place on the island of Giglio. This is an Italian island situated in the coast of Tuscany. They think that promoting blue energies can help in the transformation of the island into a self-sufficient territory from the power point of view. So they are looking for experts in blue energies able to provide innovative solutions to insert blue energies in the Giglio island. The second challenge comes from ENEA. ENEA, the National Agency for New Technologies, Energy and Sustainable Economic Development. The municipality of San Felice Circeo, located in the region of Lazio, in the center of Italy, Mediterranean coast, propose the realization of a simple infrastructure for charging small electric vehicles powered by wave devices to be located around the infrastructure of the port in order to enhance and promote sustainable mobility in the city and in the nearby National Park of Circeo. Then we have the third challenge. It comes from Valencia in Spain. We are presenting a challenge from the Valencia City Council. Valencia City, in its fights against greenhouse emissions and climate change, cannot turn its back on a resource as important as the Mediterranean Sea. So the challenge is about the design and installation of a platform that combines various forms of marine renewable energy in the coast of the city of Valencia: wind, waves, solar, and hydrogen. The solution can include other utilities related to the blue economy to be integrated in the platform, such as agriculture, tourism, or other activities. Okay, then this challenge is proposed by the Split Dalmatia County in Croatia. They are worried about how to prepare the educational system and skillful workforce for the development and deployment of novel blue energy technologies. So they are looking for consultants, governmental bodies, entities working in the field of vocational training, and enterprises that already restructure their workforce to provide guidelines, measures, courses, which would boost this transnational process and result in a successful implementation of requalification and training programs. Okay, now we have this challenge, and this challenge is looking to provide energy autonomy for the port of the city of Samos. Samos is an island in Greece located in the Aegean Sea, very close to the coast of Turkey, and it has 3,000-4,000 inhabitants. Oh, sorry. And the island is looking for original ideas and proposals with sustainability, innovation, and job creation prospect to achieve energy autonomy in the port of the city of Samos, using blue energies and respecting the natural landscape. The Center for Renewable Energy Sources and Saving is the Greek national entity for the promotion and renewable energy sources, rational use of energy, and energy conservation. They look for organizations to develop long-term monitoring of underwater activities close to blue energy devices. The systems could include optical, acoustic, chemical, or physical monitoring devices, or any other devices or sensors to be considered appropriate. The system should be compact and easy to transport and deploy on blue energy devices, weatherproof and capable for long-term unattended operation on marine environment. Remote monitoring and data transmission would be a significant benefit also, okay? Levantina Fish. Levantina Fish is an important fish farm located near the port of Limassol in Cyprus. The company is looking for marine renewable energy production and power supply for use by feeding platforms in aquaculture. Levantina Fish would like to use marine renewable electricity to power its two feeding platforms that supply two different fish farms daily with the exact amount of food needed by the fish. These two platforms are estimated to operate 350 days per year, 6 hours per day from 7 to 13 p.m. And now they run on oil, so they want to change this, okay? Enerocean is a small company located in Malaga, in the south of Spain. And also they have an office, and they are located also in the Canary Islands. This is the oldest Spanish company exclusively dedicated to marine energy engineering. The company has developed an innovative floating wind platform. And the company, this device allows optimizing the cost of energy production by having two wind turbines of 6 megawatts each on the same platform. The company is also worried about reducing the marine visual impact and green energy generation. So they are looking for solutions to improve visibility and the possibility of detecting the presence of the devices at sea in a way that it's more acceptable by the population and has less visual impact. The port of Sarande is a port of Albania in the city of Sarande, and they need to develop a system to use a seawater heat pump in the main building of the port of Saranda. The project concerns the installation of a geothermal heat pump with the aim of covering thermal and cooling needs in the indoor preheater of the building port of Saranda. The proposed heat pump will operate with seawater, not directly from the sea, but through drilling in close proximity to it. Marina di Pescara is located in the municipality of the same name. Visitors and boat owners will find this marina in the province of Pescara and the Italian region of Abruzzo. The marina wants to test systems to generate electricity from waves and select the best technologies, able to provide solutions in order to fully supply the energy demand of the port. Larnaca is a city on the southern coast of Cyprus. This is the third largest city in the country after Nicosia and Limassol. Wanting to contribute to the effort to tackle the climate crisis and promote the use of renewable energy sources, they are looking for innovative proposals to turn Larnaca algae from a problem into an opportunity. Their goal is the sustainable use of algae to bring mutual benefits to the citizens and the environment. So they are looking for a conversion of algae into biofuel, okay? And the last challenge we are presenting comes from FAMP, which is the association formed by the Andalusian local entities, municipalities, provinces, and associations for the defense and promotion of local autonomies and the defense of culture, socioeconomic development, and the values of Andalusia. The challenge is based on the need of a model that enables to have a governance structure at local level, so that national plans, strategies can be implemented and thus take advantage of the unexploited BE potential of the Andalusian coast, identifying the kind of actors and their role in the blue energy production. Okay. So these are the challenges we have. We have 12, and let's summarize the challenges a bit. Okay, so we have seen that they are different. They are all related to blue energies. They have some trending topics working in our project, Blue Deal, marine port technologies, renewable energies, technologies in these renewable energies, blue energy impact on society, training and local governance, okay? And there are also other interesting topics, as for example, algae and how they can be used, fisheries or farm fish and their energy needs, devices to detect blue energy technologies at sea and to make them more accepted by society, or the energy autonomy in general. So what's next? Now we have the 12 challenges, okay? So this is a calendar we are presenting where we tell you how it's going to work. We have now the 12 challenges. We are going to disseminate them. They are going to be put in the Blue Deal platform. And well, they will be there and you can participate if you want, proposing your solutions. We will be collecting these solutions through this Blue Deal platform until end of September, October, when we will select, there will be a jury and they will select the finalists. And then will be notified in November, and in February, we hope to do a business forum in Valencia, according to our project, and we will take the opportunity to present the finalists, and we will do a jury to select the winner of each one of the challenges, okay? We hope this event in Valencia will be face-to-face, so we will be able to see you all, okay? So This is the calendar we have. So now we have time. The challenges will be published in the website, and you have time until September to present your solution. So there is time to do it. This is the platform we work with. Here you have the website, and there you will find the 12 challenges ready, so you can submit your proposal. It will be very simple in a short document, not a lot of text, okay? So you can present it. It's very easy, okay? So thank you very much. I thank you all for your attention, and hope you will submit your proposals and you will give us some solutions to this interesting challenge. Thank you very much, and let's make a blue deal.
Thank you very much, Carmen, for your first presentation of the day and start of these challenges that are coming in the second part of our project. So we are now ready to start the second video that is coming from the university students that were basically working on the Open Innovation Challenge that I put in front of them. So you will see it will be an interesting solution they found for the Open Innovation Challenge. So the challenge that I put in front of them is how to use the blue energy technologies for the submerged archaeological remains in the Adriatic Sea. So I'm very satisfied with what the students did, and hope you will be also.
Hello, my name is Josip Miškić, and today I will, in name of my colleagues from the faculty, represent you solution for the setup task. The task was related to submerged archaeological remains in the Adriatic Sea and how to preserve and connect them with the blue energy solutions. The main focus was to find the answer how to make submerged sites safe from neglecting and damage due to marine activity or human actions. How to make more attractive and bring back life in these sites with the usage of renewable energy, precisely blue energy, the energy of the sea. So the main target is to meet past and future, and to make future becoming a present. To achieve this goal, we leave our mind to the imagination and collected our ideas. It was really interesting to see how many ideas we catched and put on the table as a solution. But before we bring our idea on the light, we needed to detect problems and set our goal. The two main problems we detected is a very conservative way of protection of submerged sites. Today, the usual way to protect sites is to put on them an iron cage. The opinion is that we on this way protect sites from theft, damage, and decay. But in other hand, we make these sites unapproachable and we don't have any benefits of them. Simply to say, well, it's not attractive, practical, or profitable. Second problem was that Croatia is recognized as a well-known tourist destination. This title brings with itself a significant number of tourists. So there is always need to find new tourist offer to keep this number on a high level. This number of attendance can potentially be a problem because overexploitation of the coast in sense of building houses, apartments, or hotels. The problem can be especially in a coast zone where we can find the submerged sites. And besides, the more tourists come, there is a higher possibility of irresponsible behavior in a zone of sites. And because of that, there is always a higher possibility of damaging them. Having this problem in mind, we look for solutions which can satisfy both problems. And in our thinking, solution must simultaneously satisfy safety standards and standards of attractive tourist offer. The basic guiding thread was to find new security and monitoring system and how to create offshore tourist destination. The base of our thinking were blue energy technologies, which were a link between problems and solutions. The technologies can be different, from floating buoys, offshore wind farms for producing electricity, heat pumps for heating and cooling, and etc. On the next slide, we will present for which technologies we decided to use. And here is our solution. Our solution is to build a floating platform near the submerged archaeological site. Idea is to organize scuba diving on archaeological site with entertainment content as a hunting treasure, participation in the site conservation, and different educational tours to meet the marine environment. There will be a catering offer in a term of serving food and a drink for refreshing. And the platform will use wind energy from windmill and sea energy from floating buoys. The producing energy, of course, electric energy, will be used for charging platform batteries, producing oxygen for scuba divers, and for a desalinization process to make drinking water for platform customers. To approach to platform, there will be a taxi boat, of course, on electric energy with electric batteries. So the taxi will recharge from the windmills or buoys. To develop this idea and strategy to implement it, we use business model canvas, and in the next few slides, I will present it through a few most important aspects. In order to ensure successful implementation of this idea, we need a lot of different partners in different business areas. Due to our wish to be more tourist attractive, we need cooperation with tourist agencies, communities, and maybe some cultural societies. To achieve safe diving, we need also diving clubs, diving instructors who will provide short safety and behavior courses. And on the end, we need support of producers of diving equipment to have always technically correct equipment. To explain our business canvas, we will start with values we will try to offer and create from implementing ideas, technologies, and services. The benefit of a business idea and solution is, first of all, nurturing and promoting of cultural heritage. There will always be on the site some ships when there is always some story about battles which happened there and something like that. The next value we create is a sustainable tourism, energy independent platform using blue energy from windmill, floating buoys, and the rest of the values are amusement, relaxation, recreation, and adventure. Key activities which will ensure creating our proposal values are divided on the three parts. First parts are activities due to existing archaeological site. And the main activities in these parts are surveillance and maintenance. In second part are activities due to tourism, and activities from these parts are diving, historical tours, taxi boats, relaxation, catering services, snacks and drinks, and entertainment. Third and the last part are activities due to implementation of technologies. Of course, renewable technology and blue technology, and that activity results with producing of electricity, oxygen, and water for drinking. In order to be able to offer value, we must provide the means to implement the service by which we'll achieve this. This category is also divided in three parts. First part is related to resources we need on submerged sites, and there are security cameras, detection sonar system, the elimination buoys, and educated staff who will ensure providing all services safety. Second part is related to resources to accomplish tourist attraction. Those resources are a platform, diving equipment, taxi boat, and stuff. In third part are resources related to which will ensure using of blue energy, renewable energy, and the key resources in this group are a floating windmill, wave energy converter, a desalinator, air compressor, and a battery system. In order to create a complete picture, we offer this image to create a sense of what we offer and what we want to achieve. It contains at least most of resources, values, and services that we want to provide. We see here a floating wind turbine, a desalinator, air compressor, battery, wave energy converter, taxi boat, etc. And since we are creating values, they are also intended for someone. And there are certain groups of people who will use these values, and we suggested few of them. As it says on the slide, we offer our values to tourists, histories, enthusiasts, explorers, diving clubs, and etc. To bring this idea closer to customers, we need to reach them through the certain channels. Channels we picked to use for advertising are social networks like Facebook, Instagram, and Twitter, websites, maybe like booking, tourist agencies, and information panels and posters. To accomplish this idea, we will have different type of costs, but some of are the foremost. And they are investment costs, which are expected to be higher one, maintenance cost, variable cost for staff, utilities, research and development, project development costs, and there is a fee for the usage of a cultural property because the sites are usually the state-owned protected area. In order to satisfy costs, we expect revenues from our activities. Revenue is expected to come from maintenance and surveillance. Maybe the state will pay us for the surveillance of the site. We expect revenue from tickets, maybe different type of tickets, all inclusive, only for entrance, revenue from diving courses, equipment rental, revenue from a taxi boat, revenue from the souvenirs and catering services. Also, we will have some additional revenues because we produce electricity, and the produced electricity we can sell to the boats coming on the dock. Also, we can use the produced electricity to produce oxygen and water for drinking, which we can sell to the customers of platform. So we are coming to the end of this presentation, and we have a little simple conclusion. In order to solve this challenge, we tried to be creative, and it was really productive for us. It was very interesting to see how everyone can put a piece of their idea on the table to create something new and innovative. It gave us new opportunities to think about it and to see how sustainability is possible everywhere, no matter how demanding task it is. It was very instructive to see possibilities of blue energy and offer from the blue energy to us, and that it is very significant to us to see how to combine blue energy with different services and values, such as the preservation of submerged archaeological sites. And with that, we are coming to our last slide. And on the end of this presentation, I want to thank to my colleagues who let me present you this idea, and I want to thank Professor Hrvoje Mikulčić for opportunity to present you this idea, and I want to thank also you for your attention, and I hope that you don't mind my serious face. It's quite weird to talk on screen without any interaction with anyone, and that's all from me, my colleagues, and one more time, thank you and goodbye.
I think the students, I can say that those that are physically here with us and listening to the presentation were enjoying it and are satisfied with the idea that you put as a solution to the made challenge. So this is like a driving solution for all others that are dealing and will be dealing with the open innovation challenges that Carmen has previously presented. I hope that the students are online and that they are satisfied with the outcome of their work. But now we are continuing to our next presenter. Our next presenter is Mr. Damir Buzov. He is a mechanical engineer. He is founder and director of the SmartF Energy, a small company in green energy efficiency project development and execution. He will be talking about the perspective for renewable energy sources in Croatia. And he will make his presentation in Croatian, so the online presenters have the possibility to switch to the simultaneous translation into English. Basically, that's it. We can start. And another thing that I forgot to say, please, those who are online, fill in the questionnaire that is available online, so we have your feedback on your satisfaction and how to improve further our development within the project. So, Damir, please take over, and yeah, that's it from me.
Dobro jutro, je li se čujemo?
We hear each other. Great.
Podijelite ekran samo da vidimo prezentaciju.
Please share the screen so we can see your presentation. I'll need just a minute for that. Now we can see the resolution of your screen, but we need a presentation. Okay, it's fine now. And then click full screen, please.
Evo, znači...
Može samo, ispričavam se, može samo full
I
screen.
apologize for interrupting. Can you just put it on full screen because we can see the other slides as well at this point? So,
Piše postavke prikaza.
where you have the screen options, you should click on that.
F5 može. Na tastaturi. F5. F5. I sad na vrhu tu ima ovaj postavke prikaza.
At the top you have screen options, so you should click on that. That's it.
Bravo.
To je to.
Možemo krenuti?
We can start now.
Evo, kazat ćemo...
So, in this short presentation, I will tell a few words as regards to the condition and perspective of renewable energy sources in the Republic of Croatia. My presentation will be on behalf of Smart Hub Energy, but also on behalf of the Croatian Chamber of Commerce and the sector for renewable energy sources, because I'm a president of this section. We are living in a time of great challenges referring to the preserving of environment and stabilizing problematic state that we have as regards to gases emissions in the atmosphere. So on one hand, we have a challenge that we haven't recorded until this point, but it determines the sustainability of life on the planet. And on the other hand, we have the framework of the European Union, and we have a kind of, we can call it a sacred format within the European Green Plan that determines the strategy to achieve sustainability of economy of the European Union in the upcoming period. As for renewable energy sources in the Republic of Croatia, we have to emphasize what this means. So this is kinetic wind energy, sun energy, biomass, heat energy of interior of the earth, potential water energy, and sea energy. So in the Republic of Croatia, in the sense of meeting the aims for the previous period, we can see here what's the condition now on the graph. So the Republic of Croatia is kind of here. You can see that it met and that it exceeded the aims for 2020. And these aims were set at 20% of the realization of decrease of the emissions. And as for the numbers and as for the values, we exceeded this aim for approximately 30%. In 2019, what we can see here in the graph, so the blue columns indicate how much energy we produce from renewable energy sources in relation to the complete needs of energy in the Republic of Croatia. So we are at around 30%. Within these 30%, we have a dominant portion of energy of electricity. So 50% refers to electricity and 37% is heating and cooling. As for the structure of production plants, so power plants for electricity production from renewable energy sources, in 2020, we can see that most of it referred to wind power with 717 megawatts, and the solar energy, which is the most represented in this part, is only 53 megawatts. This means that dominant portion refers to wind energy on one hand, and on the other hand, we can say that there is a great potential for the development of solar power plants in Croatia. As for the companies that we have on the market, we have 10 greatest companies dealing in this sector, and you can see them in the table. So the greatest system is definitely HEP, and then Prvo plinarsko društvo. Then we have many associate companies of HEP, such as Operator distribucijskog sustava and HEP Elektra. In any case, these companies are established companies at the market, and they control, we can say, like total supply, energy supply market. As far as the other segments of market is concerned, we will say within a few next minutes, we will talk about this. So greenhouse gases emission, its structure is such that it is derived from several different sources. We can see that we have dominant influence arising from traffic, from burning the fuels outside of the transport itself, and the energy and the industry. So in this section, we can say that main directions of development for the renewable energy sources in Croatia would be through the production of electricity through renewable energy sources, gas with the corresponding infrastructure. We also have to emphasize the development of electromobility in land transport. For us living in the coastal area and in Split-Dalmatia County, it's interesting to see electromobility in sea transportation. One of the great challenges is to decrease CO2 in construction industry, because they are a great emittent of CO2 when we consider total portion. And there is also an aspect of increasing energy efficiency in the industry. What we can emphasize is that renewable energy sources provide a great opportunity for the development of economy in the Republic of Croatia. Actually, the development and the application of advanced technologies and solutions arising from renewable energy sources. This will mark the decades which are ahead of us, and this presents a challenge for Croatian economy. It's a great challenge, and it has a potential of important step forward to foreign market. What we can emphasize as main challenges in the market development and project development as far as renewable energy sources are concerned is legislation that in one part does not encourage enough energy savings. And I'm sorry, we can't hear him anymore. And proposals arising from energy. Okay, so we got cut off again.
Proizvodnim sustavima energetskih pregleda nije toliko
This is not something that leads to implementation of the improvement after that. There are relatively small funds and tenders for financing energy efficiency and renewable energy sources for small projects. So I'm talking about the projects up to 150,000 euros of value. So another thing that needs to be emphasized is that the tender modality is partially destimulating. So most of the tenders are implemented in accordance with who comes first gets the money, basically. And with such model, it is hard to ensure and to, have in mind that you are going to get some tenders. So you can't count on the realization of the solution in planning of the project itself. Finding the best solutions in this part presents a significant challenge in increasing the dynamics of implementation of projects, including renewable energy sources. And this is actually a challenge for a complete Croatian society. Thank you for your attention. That would be, in short, what I wanted to share with you. Thank you to Mr. Buzo. We had some technical difficulties with your connection, but mostly it was clear and we could keep track.
I would just like to highlight that we have over 300 participants online, so it's quite a large community, and we see that we are building on this momentum and that the community is growing. So we like it, let's do it, and let's continue the good work. And also to the students that are online, I'm pretty much sure and that everyone is satisfied with your work and good work. So we continue with our next presenter. Our next presenter is Dr. Ivan Visic. He is the CEO of the Pro Integris Limited company. They are working on substation automatization, protection and control systems. The company is from 2004 run from Split and works on different power automation projects. So we are switching to the industry presentations, and I hope that all of you that are listening will be interested in it. So Dr. Visic, the floor is yours.
Okay, hello everyone. It's glad to be here. It's nice to see you even in these short numbers, but hopefully we will see you in some next time here in a beautiful hotel and in our beautiful city. So where is the control? Yeah. Okay. So my topic, the topic that I will be dealing with is our experience on working on offshore wind projects. Before saying few words, I will tell a few words about our company. So generally, we are founded in 2007 with the idea to give to our customers optimal and innovative technical solutions in the area of substation automation, protection and control. Our goal was to gather together and employ best engineers in energy automation. So basically, we would like to be seen as a system integrator And our two basic areas where we work is substation protection and automation and design of power systems. So practically we work in all areas of in energy sector and industry. So it means production, distribution, distributed generation, and in this way we came to the also the opportunity to work in the wind business. If you look at the map, you can see that we, as a company, we work worldwide. So as I said, working in energy sector, we came into the opportunity to work also in the area of wind business. Practically, for us, working in wind business is not a lot different with working in any other substation automation systems. We started to work with some basic primary testing like current and voltage transformer testing, and then with the time we developed our cooperation with companies working in this business with protection testing, some engineering, doing engineering, SCADA system testing, and similar things. On this screen, you can see the list of the projects that we already participated in. So it's there are lots of projects. Recently, the two latest projects we are working now is Hornsea 2 project and Changhua projects. So these projects are started. They are performed now in Singapore, and we have today more than 10 people working directly in Singapore in shipyards. You can see from the screens that, for example, Hornsea 2 has 1.4 gigawatt, will have 1.4 gigawatt installed power. In comparison, Croatia now has around 2.2 gigawatt consumption. So it's a huge amount of energy, and you can see that this will be produced in the 165 turbines. I think it's around 8 megawatt per turbine. So basically, there are two ways of transporting the energy from the wind farms to the shore. So you have this one is with offshore AC substation, and which is at the sea. And in this offshore AC substation, you have transformation from some middle voltage to high voltage, and then with the high voltage cable, the energy is transported to the onshore substation. There is also possibility to have a HVDC converter station in which you transform AC energy to DC transmission, and then with DC energy you go to the onshore substation where you have again HVDC to convert to AC energy. Really, I don't know the real reason. It's I think the calculation what is optimal solution for the energy transportation. Our experience so far is that we worked mostly on normal AC substation, not on HVDC substation. In this, I will show you shortly what is the scope of the work generally that we do in this wind farm business. This is the example of Burbo Bank substation, where you on this map you can see how it's geographically positioned, the whole system. So you have offshore substation in the middle. You have 8 strings with 4 turbines per string, and each string has 4 turbines, each with 8 megawatt. Yeah. So in a shipyard, the offshore substation is constructed, and then erection and whole testing or whole power system is done in a shipyard. As you can see from the slide, the estimation of the time is around 3 to 4 months for the construction and 3 to 4 months for the erection and testing in the shipyard. So we have in a shipyard we have high voltage substation and middle voltage parts. High voltage parts, here you can see the picture that this is 220 kilovolts GIS system, gas insulated system. This is if you don't know, this system is usually used for when you don't have enough distance for such a high voltage. Then you are using this technology, and this system consists in this substation of one single 220 kV bus bar with two transformers and one export cable feeder to bring the energy to the onshore substation. There is also middle voltage switchyard, which is for Burbobank was 34 kilovolts GIS. Again, there are two identical separated systems, 8 strings that are per feeder. Per each feeder, you have 8 strings, which I presented before. You have 4 transformers feeders and 2 bus couplers feeders for connecting the parts. The power transformers are, we have 2 power transformers which are stepping up the voltage from 34 kilovolts to 220 kilovolts. Each transformer is 200 megawatts, and they are the cooling is oil natural, air natural. And what is the specific is that radiators are mounted outside of the house, which is normal because we are using the cooling of the wind to cool also the transformers. So basically, when the work in the shipyard is finished, we have to transport the platform, and we have to transport the base called jacket to the sea. For this, barge is used, and for this work we need around 2 weeks from sail away till placement. For Burbobank, the offshore platform was based in Irish Sea, so the time was around 2 weeks. Generally, as you can see, the base, there are different ways of the foundation of the wind farms, wind turbines, and also of the platforms. Mostly so far we are using this monopile foundation because in Irish Sea and the Northern Sea, where all those projects where we worked in were installed, you have you have depth of the sea not above 30 meters, but there are also some other ways of turbine foundation. If you compare the turbines that are produced so far, you can see that in 1991 the turbine was 0.45 megawatts, and diameter of blades was 35 meters. Today we arrived to 8 megawatts and more than 160 meters of diameter. And as far as I know, today we are producing also wind turbines with 10 megawatts and more. So here you can see how the platform is, this offshore substation is mounted at the sea. There are some conditions that have to be fulfilled to work at the sea. So there are certificates we have to obtain, like GWO certificate, and if you have to arrive to this platform at the sea with the helicopter, then you have to pass the training. There are also some equipment special that we have to use at the sea. So you have to be trained and educated to work at the sea. You can see a nice picture of the turbine in comparison to the ship that is transporting the people to the turbine. So the difference is rather high. Of course, for each wind farm, we have the base from which the ships that are supplying the wind farms, transporting the people to substation are they are departing from this kind of such kind of base. Generally, what we have to think at the sea is also how to accommodate the people. Usually, in wind farm business, it's we like to avoid to spend lots of time at the sea because of the weather conditions. So you cannot work normally at the sea like you can work in the shipyard. So most of our work generally is done at the shipyard, but you have to also to do some work at the sea, and for this. We use jack-up vessels. They are like hotels at the sea close to the platform, and on those vessels are hotels where people live during commissioning and installation phase. There are also some particular and special boats that are used for example, for cable laying. For cable laying, you put the rowboat into the sea to pull the cable to the platform, and from the platform, this boat for cable laying is pulling the cable to the coast. And also, you can. There are special boats that are used for turbine mounting at the sea. At the end, when we commission and put into the service the wind farm, you have different SCADAs that are used to supervise control of the wind farm. Here you can see one example of the wind farm SCADA with which you are supervising the production of each turbine, or you can see if there are any problems on each turbine. So yeah, so generally, somewhere in the invitation to this presentation, I saw the question: what are the benefits of those wind farms? What could be the benefits of those wind farms or offshore wind farms for the local community? Generally, from my perspective, I can say that this would mean more work for shipyards and more work for our power industry here. And for a local community, I can see the produced energy. So because if you can produce some amount of energy, this would mean a lot for the local people and also for the whole country. So okay, here this is the end of my presentations. We are a company from Split here, but we have also the offices in Zagreb. Thank you for your time. Yeah.
Thank you for your presentation. It was an interesting one to hear the industry perspective on the blue energy technology development. So we continue with the industry talk. Our next speaker is Mr. Darko Uršičić. He is an offshore wind project planner from Flow3 Limited Project Management Consulting Services. He will be talking about the offshore wind energy developments, the current status, the challenges that are upon us, and the future perspectives. So, Darko, are you with us?
Yes, I am.
Okay, so the time slot is yours.
Yes, thank you. So a very short introduction. I'm project planner. I'm working on offshore wind farm projects since 2014. Most of these projects that were listed from ProIntegris, the UK projects, I was involved in that. Overall, from 10 gigawatts of UK projects installed, I was involved in about 1/3 of it, 3.2, 3.3. And what is my idea of this presentation? To give a short introduction. Then I have some slides that I prepared 3 years ago. And then it was very interesting to me to see what changed in the past 3 years. So I think that should be the accent of it. And in the end, I would give a short introduction of what is my opinion, what are the best, best areas for Mediterranean industry to concentrate where they can make an impact when the projects start in the Mediterranean area. Anyway, this is my name, and then this is very short introduction. What is the status? There is lots of times there is a talk about some great growth. Yes, there is a growth, but for the recent 4 years, then the number of installed turbines or capacity of installed turbines offshore is fairly flat. And even in 2020, there was this smaller number. Why? It is not COVID. If you look at the countries, two biggest countries, UK and Germany, had less turbines installed last year. So that is the main reason. I think this is just statistical anomaly, so it will change. In the next slide, we can see the breakdown of European countries. And if you see that there is total 12 countries with some installed capacity, but you can disregard for now everything after number 5, because countries, UK, Germany, Netherlands, Belgium, and Denmark have, I believe, 99% of overall installed capacity. All others have, few turbines installed and just some, I don't know how to call it, learning projects ongoing, like 1 turbine and similar. 2 turbines. Then next, I think this is the industry view. What are all the offshore wind farm packages that are to be done in order to have a completed wind farm? On the left side, there are asset offshore wind farm packages. We call it asset. These are physical packages. These are the things that we have to build, that we have to complete in order to get power running. On the right side is in internal offshore wind farm packages. This is just the works that has to be done. It is not physical. It is mostly some documents or some processes that have to be completed in order to finish everything. On the left side, asset packages are wind turbine, of course, foundations on which turbines are built, interarray cables that are connecting turbines inside the wind farm. Export cable is connecting the wind farm to the grid overall. There is HV equipment, of course. These are all the high voltage transformers, switches, and similar equipment. SCADA and protection, that is from colleagues from ProIntegris, are experts in. Offshore substation, there was a picture in the previous presentation also. An onshore substation, it is not different in any way than similar substations for other types of power plants. And then for internal packages, there is consent. Of course, for every works, we have to get a consent from government, from nature protection authorities, and similar sometimes from military, from airports, from all the different branches of government that could be impacted by building a wind farm. Commercial is just procuring everything that is needed to build a wind farm. Site investigations, it is investigations, geological investigations, and investigations from unexploded ammunition and weapons from previous wars and similar. That is actually very important. Construction site, it is just we have to make this temporary harbor site when everything is built and sent offshore, and that is a big project in itself. Divestment is preparing to sell off the wind farm after it is built. So developer usually does not keep the wind farm forever, but they develop it, and then usually they sell off part of it, maybe 50% or similar, to investors like maybe pension funds or similar. And the third one is the last one is transferred to to operation and maintenance. It is just a transition from this construction part to regular exploitation of it. Most of these asset packages I will describe in a more detail later. Then two key trends. One key trend is the rated capacity of turbines. You see that around 2010 it was around 3 or 4. The past year it was 8.2 megawatts. And when you are considering some future plans, please don't think about turbines that are maybe 5 or 6 megawatts. If you're talking about 2025, there will be turbines of 14 megawatts. I don't have a good clear picture what is going on after 2025. But for example, I'm working on a project that will be installed in 2025 and 14 megawatt is the turbine that is used. So please take that into consideration, the growth of turbines. Other key trend is the growth of depth for the foundations and the growth of distance to shore. Depth is mostly important for type of foundations. In the shallow water, it is always monopiles. Then as we get deeper, it is jackets. And if we get very deep, then it is not possible for jackets. It is for floating foundations. And distance makes most difference to substation and export cables. For example, when you get very far from offshore, there are different cables, and there will be HVDC, direct current, high voltage cables used to connect this. Also, substations needs to be bigger, and everything needs to be a little bit different than near shore. And then we go to going through these different packages. The first one is foundations installation. The vessel is floating crane. This is a floating crane or jack-up, but mostly it is floating crane because this is the way how it is done. On this picture, you can see how the floating monopile is pushed by tugs, to this area below the crane, and then it is appended and positioned, and after it is hammered down. It is sensitive. This process is sensitive to weather, to waves and wind. We cannot do it in strong wind or in big waves. The greatest risk are the seabed conditions. There are these investigations, they are performed, but you never know. There could be some boulders. Boulders are like big rocks that are present underneath the sea bottom, and other condition is erosion. You do some investigation, and after maybe 2 years, because of erosion, the sea bottom can look very different than it was then. The problem with survey, this geophysical survey, is limited depth. We cannot properly survey the full depth in all the locations. So that is always one risk coming from them. Scar protection, it is just dumping of big stones that are designed to keep the area around the foundation, in place, not to be impacted by erosion. The most environmental impact is the noise during the installation. So when it is hammered down, it is a big noise. It can have impact maybe on sea life. And then there are some solutions. One is to have some kind of protection. It is like a screen of bubbles that will make the noise smaller. Or other, it is usually limited period. For example, you can do it only maybe from April to October or whatever are the animals. Animals can stand the best in that area. Transport for monopiles is barges. They are pulled on barges. Monopiles can be floated if it is near shore, not if it is very offshore, because then it is risky. Hydraulic hammers are used for monopiles, and transition piece, that is the yellow part that is usually coming on top of monopile. It is lifted on monopile and it is grout connected. There are some wind farms in the future, from maybe 2-3 years in the future, that will be installed without TP. So tower will be installed directly on the monopile. We will have to see how it is going. It is, the idea is to be simpler, to be cheaper, but we have to be more precise in that. For jackets, everything is very similar, just they are not hammered down. They are just the corners are hammered down with piles similar to this monopile. And floating is a bit different, but then you have again fixing it by anchors. That is in a way similar operation to this. Next work package is wind tower. generator installation. Every wind turbine has tower. This is tower, a nacelle, the part where the generator is, and 3 blades. We have nacelle factory and blades factory, and tower sections are sourced from outside. So if you have a supplier, and there are 3 big suppliers, they are Siemens Gamesa, it is Vestas, it is GE. They produce nacelles and blades internally. They have factories for that. Tower sections are coming for suppliers. So if it will be in the Mediterranean, probably they could have some suppliers in the Mediterranean. As I know, some sections are already produced in Spain, but I believe it is Atlantic coast of Spain. There is a pre-assembly site in harbor where towers are erected. So 1, 2, 3 sections are built, one on top of second and on top of third. And then it is installed with the installation vessel offshore. On the pre-assembly side, nacelles are completed, blades are repaired as needed. Vessel to be used, it is always jack-up. We cannot install the turbines with floating vessel because of the movements. We cannot install turbine in that way. It is very sensitive to wind, so wind limit is around 12 meters per second for blades. Tower and nacelle you can install sometimes in slightly stronger wind, but not the blades. They are light, they are very long, they are you have to position them very precisely. So wind is the problem. The risks. The seabed is the risk for jackup because this vessel has four turbines, let's say 4,000 tons on deck, and it is a weight of the vessel, and it has to make a jackup. And sometimes if the seabed is not perfect, then we have to stop and we have to move to another position. The other risk is of course lifting. Always when you lift something like this offshore, there is a big risk that something goes wrong. One vessel installs 4 to 6 wind turbines, then returns to pre-assembly harbor. At finish of installation, wind turbine is energized, or if it is not energized from the array cable, the diesel generator is started because it has to run at least to keep the climatic conditions inside to be dry and to have some basic controls in it. What is the difference from 3 years ago? Now the new turbines are bigger, so the current installation vessel are not perfectly suited for them. So some current installation vessel are getting better cranes, they are getting improvements on cranes, and there are other systems. And other solution is of course the new vessels are being built. One new vessel, I'm not really in that business, but I will say that price for one vessel could be maybe 300-400 million euros. So it is really big investment, and it is never built for one project. It is built if you have a good pipeline of projects coming. Then second package is wind turbine commissioning. Vessels are DP2 flotel vessels like this one below on the picture below, or crew transfer vessels. These are small vessels like the small vessel behind the big vessel in the picture. In the past, when wind farms were close to shore, it was possible to do everything with smaller crew transfer vessel, and then crew is every night they are sleeping, on shore in the hotel. But as wind farms are very far now, for example, Hornsea wind farms, you need to sail for almost, 9, 10, 12 hours, depending on speed. So it is not possible to go, to go onshore for every night. So people are sleeping and they are living there for 14-hour shifts. So they were 14 days offshore, 14 days they are back at home taking a rest. The commissioning is sensitive to waves. So if there are waves, you cannot transfer people to wind turbine. Usually all these vessels have some walk to work gangway. It is hydraulically compensated gangway that is used to connecting to turbines. What are they doing there? They are completing the remaining completion tasks, for example, low voltage or lift completion or whatever. Ideally, all that should be done onshore in the harbor, in pre-assembly harbor, but it is not always so. That needs to be done before they can do the proper commissioning. And then in the proper commissioning, they have to do these processes. They have to close the checklists that are needed before starting the turbine. And then wind turbine is started, SCADA tests are done, and similar after that turbine is producing power. There are some contractual things like walk down with 3 parties, so with installer, with the owner, and with a third party that is like, I don't know, Lloyd's Register or whoever is doing it, one of the classification societies usually. And very important step, after successful commissioning, there is reliability test. It is usually 240 hours. And that means during these 240 hours, they can have only some limited errors that can be done. Otherwise, it has to be repaired and tested again. There are also takeovers like our service and finishing, and the last item is handover to service. Next package is cables installation. We have 2 types of cables. Export cables, they are, for example, 132 or 220 kilovolts, and interarray or 33 or 66. It is not all. I just given examples for you to get an idea of what are these types of cables. HVDC, high voltage direct current, was not yet used for UK wind farm, as I know it was used on some wind farms in Germany, I think in the past, but this very far wind farms that are being built in a few years, they will have HVDC. So it is Dogger Bank and Sofia. You can look for them. They are almost 200 kilometers from shore, so it is around 120 miles, and they are having this new system with high voltage direct current. So for cables, we need cable installation vessels. They can be different vessels for 2 type of cables. It can be same vessel that is only, loading different cable. They are sensitive to waves and current. For export cable, beach, pool, it is even tide. So you cannot do it at any tide. You can do it at a perfect moment for a tide. The most damage is damage to cable. Cable can be damaged in installation, in backfilling. Backfilling is covering with material on the sea bottom. During the termination by third-party vessel, there were even some damage done by cable protection that was seen recently. People usually disregard this as not so important package, but it is very important. If you look at some statistics, the most damage, the most risk was on the cables, and this is not new technology. This is something that was done for decades already, but still we have many risks that are not perfect. So first step is site clearing and unexploded ordnance removal. After that, it is trenching, preparing of crossing of other cables or pipelines. Then it is cable pulling. That is what we have here on the picture. That is cable pulling vessel. It is pulled from one side up to cable protection or J-tube on the foundations or substations, or it can be wet stored. Wet storage means just it is protected and dropped on the bottom, and it will be pulled to the foundation later. After installation, it is backfilling with material. Cable ends need to be terminated, and after everything is done, it needs to be surveyed. Surveyed is if everything is crossing other cables in a proper way, if everything is protected as it should be. When there is an export cable, there are additional activities. There is beach pull when the cable is pulled onshore, and usually it is used horizontal directional drilling. So it means they are just drilling below the beach, not to dig on the beach, and so the cable is exiting maybe a few hundred meters behind the beach and connecting in transition joint bay. Transition joint bay is one big kind of a box, more like a house, when there is a connected from one side the offshore export cable and the other side onshore export cable. Basically, it is location where it is connected to the grid. The last package that we will talk now, it is offshore substation. It is usually substation platform. It is this one, substation jacket and jacket piles that go into these corners of jacket. The jacket, I will not talk a lot about it. It is similar to jackets from offshore oil and gas, and the depth is not really big yet. They are usually now in depths around 40 meters or so. So it is not a big technological challenge. It is a routine. What can be a challenge? It is a substation. In the substations, this is example from alternating current. For direct current, it is slightly different, but it is basically transformers, usually two big transformers that are stepping up from 33 or 63 to export cable voltage, maybe 200 kilovolts or something on that level. There are switches for both sides, from medium voltage side and high voltage side. There are auxiliary systems, everything that needs to run it. I don't know, protection, SCADA, lights, I don't know, fire alarms, fire protection systems, similar. There are two recent examples. One is Hornsea 2. What is interesting about this substation, it is really big. It is 90 meters by 70 meters. If you were in this business, you know that that is a pretty big topside, and this increase in size is required because of this optimized design. It is asking for reduced number of the offshore substations. Hornsea 2 has 1,400 megawatts, and then if you put smaller substations, you will need many of them, and then rather than have many substations, better to have few bigger substations. The other example is from Beatrice projects. Beatrice projects is in north of Scotland. And then it is a slightly different concept. It is offshore transformer module. It is like, how to say, these different modules are just added together. They are claiming that makes how to say, improvement in less weight and cost reduction. But on the other side, it is not so, how to say, safe as a traditional platform. It is not easy to do some reworks or anything. So these are two examples of what is going on. And then for the end, I just ranked different offshore wind farm asset packages by opportunities for local companies in the Mediterranean. I think the first one is onshore substation. Onshore substation will be done by the local companies, by the local contractors. I mean, it can be done by 4-in-1s, but there is no reason why it should not be part of the local content. Then export cables onshore. It is just high voltage onshore cable. It also can be done by the locals. Then foundations, fabrication and installation. Fabrication can be done locally. It is monopiles or jackets. There are some good yards in the Mediterranean. We are very capable in it. But again, the most issue will be if they can, if they can be better than competition from Asia, because jackets are already being produced, I believe, in Dubai and I don't know what was the other location, in Singapore, or in Vietnam. It needs to be competitive to these far locations, and of course for logistics it's better to be closer. So yeah, it is a good opportunity. In installation, I'm aware some Mediterranean companies have the floating cranes that are capable of installing foundations, and they are doing it. But I think there will be also some external non-Mediterranean vessels, because I don't know if that is enough capacity. Offshore substation, it is similar to this. It can be produced locally in the yards. And installation, I don't know, installation is a risky. I think the owner will maybe sometimes prefer the more experienced contractor, but there is also area that it could be done. Inter-array cables and export cables, this is a mistake. It is not onshore, it is offshore. Yes, there are some capability in the Mediterranean countries for installation. And I know that even some of these cables are produced. I'm aware of one Italian and one Greek company that are producing this cable. So it can be also done locally. And then the last three packages, it will be a harder, because the most supply is done by big brands, and it is not easy to get there. So most of this equipment is done by maybe 3 companies in the world, and then it is not so easy to get in. One area is SCADA and protection. For supply of SCADA and protection, I don't know, but for installation, let's say the colleagues from ProIntegris are one example of Mediterranean company that is working in that area. Then HV equipment, it is also done by the usual big names in electrical. It will be Siemens, ABB, and I don't know who is the third and fourth, but you know, the big names. and I don't know if some big equipment can be done locally, if there is such capacity. And then wind turbines fabrication, there are again these three big companies. They are Siemens Gamesa, Vestas, and General Electric. Siemens Gamesa has some Spanish, is partly Spanish company also, so it could be in a way Mediterranean. And the other two are not, and I'm not seeing any Mediterranean company jumping into it. With installation, I think there is much of, capability, but there are not any vessels. So I already said about the price of the vessel and how there are very few vessels. I think for wind turbine installation, there is, 10, 15 vessels altogether, and not all are capable to do the biggest turbines new vessels are building. So this is area where it is very expensive and complicated to enter that market. I don't know. For me, that is all in this presentation. These are my contact details. If you are interested in some working, if you have some projects that where I could contribute, please. These are my contact information, contact details.
Thank you, Darko, for a very interesting presentation. I didn't want to stop you.
Okay.
You went all over your time slot, but it was very interesting, and I think that also for the participants online that are listening, because the questions are coming. So I kindly ask you that you stay with us for the open discussion that will be at the end around 1 p.m., 1:30, and we have to continue on. So our next presenter is Yair Rudik, so I hope that I pronounced it correctly. He is a business development manager from EcoWave Power. So yesterday we were listening about the seawater heat pump system. Today a lot has been said for the offshore wind power installations, and now we are going to the wave energy converters. So Yair is responsible for overseeing the sales and marketing functions of the company, as well as leading the implementation of the unique EcoWave Power Wave energy technology into new markets worldwide, including research for new projects implementation, project permitting, and other technical project functions. Yair, are you with us?
Yeah, I'm here. Can you hear me?
Yes, everything is perfectly done. So you're next.
Okay, great. Also, you pronounced the name perfectly. So
thank you.
Yeah, let me just share my
you
screen.
have to put the presentation. Okay, yeah.
Just give me 1 second. Okay, great. So okay, so I'll start. Go ahead. So as I was introduced, my name is Yair Rudik, and I'm the business development manager here at EcoWave Power. EcoWave Power is a Swedish and Israeli wave energy company that has developed a unique proprietary onshore technology for the generation of clean electricity from ocean and sea waves. So today I'm going to talk a little bit about wave energy and ocean energy, a little bit about our technology, one of our operational projects that we have in the Mediterranean, and a little bit about our future plans. So to get started, I'll just talk about wave energy. First of all, wave energy has a number of benefits. According to the European Technology and Innovation Platform, by 2050, ocean energy, which includes wave energy, can deliver 100 gigawatts of capacity to Europe, which is equivalent to about 10% of Europe's electricity consumption today. In addition, the sector can supply and create about 400,000 new jobs by the same year. An additional advantage of wave energy is that in wavy locations, wave energy can generate electricity around the clock. This is, of course, because wave energy is available both during the night and during the day, and this is in contrast to other renewable forms such as solar, which is only available during daytime hours, or wind, which is usually available in peak hours during the morning and at night. So, the advantage of wave energy is that it can really assist in smoothing production peaks from other renewable energy sources, and of course in balancing Europe's electricity grid. Obviously, another additional benefit of wave energy is that it's 100% carbon free. it's a clean source of renewable electricity, which can significantly assist in tackling climate change and help us achieve a more prosperous and sustainable year. So now, having mentioned those advantages, the question, of course, is why don't we see wave energy deployed around the world, alongside more traditional sources of renewable energy, such as wind and solar? The answer is the wave energy industry has struggled to commercialize for many years. The reason being is that most wave energy developers have taken their technologies offshore, so about 4 to 5 kilometers into the ocean, and they've done this to chase the high waves that are found in the offshore. So you can find waves as high as 15 to 20 meters in the offshore. However, this decision to go offshore has really hindered the commercialization of the industry. First of all, because there's a lack of reliability with offshore systems. There's stationary man-made equipment, steel equipment. There's not a lot of these kind of equipments that can sustain a dynamic load from a 15 to 20 foot wave. So because of that, a lot of these systems don't have a lot of reliability because they have to survive in very extreme and rough offshore conditions. So the second issue is really that they're extremely expensive and complex. Operating the offshore requires ships, underwater cabling, underwater mooring, divers, and so forth, which is extremely costly and, of course, very expensive, especially for a new industry. The third issue was that they're difficult to insure because they're so, offshore devices were so unreliable, and also because they were so expensive, insurance companies were not willing to insure these systems, and even if they were, it was extremely expensive, making commercialization very difficult, and especially scaling of projects. The last was a lot of these systems actually had a negative environmental impact. Even though wave energy is a 100% clean source of electricity, a lot of these systems require offshore mooring and mooring to the ocean floor, which does often have the ability to impact the surrounding marine climates and marine migration, therefore giving it somewhat of a negative environmental impact. You can see here actually a picture of the famous Pelamis project, which failed due to a lot of these issues that I mentioned here. It's an extremely expensive project, and it was also very complex, and unfortunately did not survive for very long in the ocean environment. So really, in contrast, and I'd say in response to these issues, we developed the EcoWave Power technology. It's a patented technology for which we hold 17 patents, including patents in Europe and the United States, as well as an international PCT. So the way the technology works is that we install floaters to existing marine structures such as piers, breakwaters, and jetties. And I'll explain how we generate electricity by this short video you can see here. You can see that the floaters move up and down with the motion of the wave. Attached to the floaters are hydraulic cylinders. In these hydraulic cylinders are biodegradable fluid. The fluid then moves through the cylinders to accumulators, which generate pressure. These accumulators are, of course, located on land. That pressure is then released into hydraulic motors, then to electric generators, which create electricity, which is then sent through the grid via inverters. Now, it's a completely closed-loop system, as that the biodegradable fluid then moves back into the system, and so therefore it's a closed system. Now, our technology has really answered those issues which I identified earlier. First of all, in terms of environmental impact, as I mentioned, we install our system on existing marine structures, things such as piers, breakwaters, and jetties. So we're not introducing anything new into the ocean environment. We're actually taking existing structures which have already had some environmental impact and turning them into sources of clean electricity. Furthermore, as I mentioned, we use biodegradable fluid. So the fluid used in our system is clean, and will have no impact on the marine environment in the case that we ever have a leak or a spill, which we have not had to date in any of our systems. Secondly, in terms of cost efficiency, so the majority of our system and all the expensive components are located on land. So everything like generators, accumulators, and so forth are located on land and not in the water, making it extremely cost efficient. Only the floaters, which you can see here, are located in the water. Now, the floaters are quite simple, and they're mostly made of steel and are meant to be in the ocean environment. And we also don't need all the underwater cabling, the underwater mooring, and so forth that are required for offshore systems, saving us a lot of costs. In terms of insurability, well, first, in terms of reliability, as I mentioned, all the expensive equipment is located on land, just like a regular power station, with none of the expensive equipment located in the water. In addition, we have a patented storm protection mechanism, which you can see here in the short video below, where in the case of extreme weather conditions or when the waves are too high for our system to handle, the floaters automatically rise into the upward position and lock into place until the wave heights return to normal. Because of this, our system is extremely reliable, and because of this reliability and the cost efficiency, all our power stations are insured by leading insurance companies. So just to talk a little about our development pathway and where we are today. So we began our journey with our technology in 2011 when the company was open. with wave tank testing in the Hydromechanic Institute of Kiev. We started there testing a scale of 1 to 100. And you can see in the picture here, during that testing, we tested a number of different floater designs in order to find the best kind of design for our system to increase efficiency. From that initial testing, once we graduated to real conditions testing in the Black Sea. And in 2014, we installed our first power station in the port of Jaffa in Israel at a scale of 1 to 5. That project was an R&D facility, which we used to do research and development activities towards the improvement of our technologies. Then in 2016, we actually installed our first grid-connected power station in Gibraltar at a scale of 1 to 4. Now, that project, which is a 100 kilowatt grid-connected system, is the only grid-connected array in the world that's operating in accordance with commercial power purchase agreement. So we actually entered into a 5 megawatt power purchase agreement with the government of Gibraltar and Gibraltar Electric, the national electric company of Gibraltar, which is expected to supply up to 15% of all Gibraltar's electricity need. That is the full 5 megawatt project, which we are looking to scale to in the future. That being said, the project has also received support from the ERDF and also from the Horizon Europe program. In addition to that project, we are also now in the final stages and in the final civil works for our EWP-EDF1 project, which is a scale of 1 to 2. That project is actually expansion of the Port of Jaffa project, which I mentioned earlier. We're now actually expanding that project and connecting it to the grid, so it will actually be our second grid-connected project. And we are actually doing this project through a joint venture partnership with EDF Renewables IL, so the Israel subsidiary of the French national electric company EDF, and through co-financing from the Israel Ministry of Energy. The project is envisioned as the first part of a public-private partnership with the municipality of Tel Aviv Jaffa, which could ultimately supply up to 1/3 of all this municipality of Tel Aviv's electricity needs. So to talk a little bit about the Gibraltar project, I'll go a little bit more into that. You can see here a little bit about the installation. So as I mentioned, one of the unique advantages of our technology is that most of the system is located on land. We're installing our system on existing marine structures. So you can see here all the installations and grid connections and so forth, all those activities are actually done from the shore side and not done from the water. Which saves us a lot of costs and is obviously much more efficient, and also significantly assists us with maintenance. As you know, in order to maintain our systems, our station managers only need to just walk to the structure and can do the maintenance from there instead of taking a ship and requiring specialized divers and so forth to do the maintenance. So it's pretty straightforward and significantly more cost effective. So you can see here the Gibraltar project, which we'll go a little bit deeper into now, was installed on a former military ammunition jetty in Gibraltar in 2016. And you can see here that the conversion unit, so the onshore part of the system, which contains all the motors and the generators and so forth, is found in a tunnel nearby, which you can see here. There's an access tunnel. Now, to talk a little bit about Gibraltar. So Gibraltar for us was really a proof of concept, a pilot project. And as I mentioned, was the first time that we had our system connect to the grid. So first of all, what this project showed is that wave energy and our wave energy technology specifically could connect to the grid for an extended period of time, which is something that the industry had struggled with in the past. So our station has been operational and grid connected since 2016. And a few other advantages of our Gibraltar project is even though the waves in Gibraltar are not the highest in the Mediterranean and, in general are not the highest, so meaning that the amount of electricity we can produce there is relatively lower than other locations, it was a great location for us to really implement our project and to do testing. So as you can see here from this wave chart, about 52% of the time, the waves in Gibraltar are under 0.5 meter. So at the moment, our system only generates electricity from waves above 0.5 meter and above. So what this allowed us to do is to do significant testing in order to expand the range of our system's generation. In addition, you can see here that there are several days throughout the year in which wave heights exceed 3 meters and can even get up to 6-7 meters. That there are some stormy days every year, which really allowed us to test our storm protection mechanism against very significant and extreme weather conditions. So we can say that the protection mechanism, of course, we've done some upgrades to it, but has been deployed successfully and really protects our system in the case of extreme weather conditions, really protecting the floaters, which, as I mentioned, rise up into the upward position and lock into place until the weather regime returns to normal. And as I mentioned, all the conversion unit, all the expensive equipment is not even found near the water. It's actually found, on shore a little bit further away. A few other things that were great for us in terms of the Gibraltar project, to talk a little bit about our experience there, is that as you can see here in this photo here to the right, the predominant wave direction for our floaters is actually from the side. So ideally, in most locations, and in our EWP EDF1 project that I mentioned, and other projects that we're developing in Portugal and other locations, which I'll touch on in a minute, we designed the system so the waves hit the floaters straight on, which allows us to have the most energy generation. But here they're hitting the floaters from the side, which actually really allowed us to test the robustness of the mechanical arms, which are the connections between the floaters and the structures that we've installed it on. In addition, you can see here that this is the Rock of Gibraltar, with whoever is familiar with it. And one of the phenomenons that we've also been able to test is the phenomenon called wave reflection. As the waves reflect off the rock or the structure that we're installed on, there's a feedback which actually allows us to generate additional energy other than just the frontal wave that we receive. So here having the rock has really allowed us to test that wave reflection and understand how much additional energy we can generate from this phenomenon. So to continue, you can see here actually a chart about our operational time in Gibraltar. You can see here the green, first of all, the period is from August 2018 through July 2019. That's our sample period for the operation of the project. You can see here that the green is actually, this is the time that we're able to generate electricity. The light blue is when, the wave heights were under 0.5 meter, so we were unable to generate as the wave heights were too low. You can see in red, this was the time that our system was in storm protection mechanism, so the waves were actually too high for the system to handle. And then you can see the gray is actually downtime, so meaning this was time we were doing maintenance for our system. So actually what we were able to really do is really improve the maintenance of our system. So here we can actually talk a little bit about our experience in real conditions. And as I mentioned, this is the only grid-connected wave energy array in the world operating under a commercial PPA. So we do have some significant experience in real conditions, and we've really been able to improve our maintenance procedures, which for the most part are quite straightforward. As I mentioned, all the maintenance is done from the shore side. So it's simple things like maintenance of motors, or small reparations of the floaters when needed, or replacing a pin of a hydro cylinder and so forth. So actually, due to the experience we gained from the training of our local power station manager in Gibraltar, so we were able to really reduce the direct maintenance and repair costs for the system over time. So you can see from in 2017, our cost was about 18%. Then we were able to then in 2018 decrease it to 9% and all the way down to 4% in 2019. In 2020, we will also be summarizing some of these experiences and having further reduction in the maintenance. So now if we look at in terms of energy generation, we can look at actually during this time period, we on average between 2017 and 2018 produced about 31% of the average electricity that we forecasted for the station at the time. What we're able to do actually, and a real advantage of wave energy, is that a lot of oceanographic institutes around the world collect historical wave data for different locations. So what we're actually able to do is tap into those wave data sets and actually do very detailed forecasted modeling for wave energy production for different locations around the globe. And it's very similar to the radiation studies done for solar or the wind studies done for wind. So same for us, we have wave studies. So, based on our forecasts, between 2017 and 2018, our Gibraltar power station produced about 31% of the average energy. But we were able actually to improve that all the way to 70% between 2018 and 2019. And of course, we are still working further to improve the production and better meet our forecasted production. Now, here you can see kind of a comparison in both. That's a significant difference between the 2 years. So now just to talk a little bit about kind of where we are today. As I mentioned, we had the grid connection project in Gibraltar, in the Mediterranean, and EWP EDF1 project here in Israel at our Jaffa Port power station, which is also located in the Mediterranean, will be our second grid connected project. And now we are also, now we're taking the next step in the development of our company and technologies to do the first commercial scale project. In 2020, we actually signed a 20 megawatt concession agreement with the port of APDL, the port of Leixões in Portugal, where we're developing a 20 megawatt project in stages, starting with the first 1 megawatt stage, as the licensing for that first megawatt stage is a quite simple, relatively simple procedure in Portugal. So that will actually be the first megawatt scale and commercial scale project in the history of the wave energy industry, which we are planning already for the next, to start already, hopefully in the next year. And as I mentioned, we're already in advanced licensing for this project, which we hope to be already in construction quite soon. In here, you can actually see the power matrix, so the production of our system. For 100 kilowatts, this Gibraltar project, as I mentioned, and our Jaffa Port project, and 1 megawatt, which is the next step in our development to already start doing megawatt scale wave energy projects. And you can see here already at a wave height of 2.5 meters, which is actually quite normal for a lot of locations in the Atlantic or in the North Sea, and even in many locations in the Mediterranean, we can have waves of that size quite often. We're already producing pretty close to capacity with a period of 6 seconds, which is the prevalent period in most of the Mediterranean. In addition to that, just to talk a little bit about Echo Wave Power, our company, at the moment we have over 200 megawatts in project pipeline worldwide in countries such as Portugal, Mexico, Australia, China, amongst others. We also have subsidiaries in Gibraltar, in Portugal, in Israel, and in Australia. So that we're looking to develop these projects in the coming years. And as I mentioned, we're looking really to start already developing the first megawatt scale project in Portugal in the near future. And we really see this project, this megawatt scale project, already bringing our technology to commercial level commercialization, which will hopefully allow us to access debt financing for future projects and really to roll out this pipeline and expand our pipeline in the future, and really to bring our technology worldwide. So that being said, we really believe that a renewable future combines all the different clean energy sources. That at the end of the day, it won't be one clean energy source which will supply all our electricity. It'll be a combination of wind, solar, and wave, and other renewables together combined that will really help us achieve this. And you can see here, we're actually testing a combined wave and solar system in our project in Gibraltar and in Israel, and we've already submitted a patent for this. Seems like I need to end, so I'll just wrap up quickly. We've been featured on CNN, Forbes, National Geographic, BBC. We actually won a United Nations Climate Action Award in 2019. We are the winners of C40 Cities, and we were actually recently recognized as the Sustainable Markets Initiative by His Royal Highness Prince Charles, the World Economic Forum, and the Bank of America. So if you'd like to find out more about our company technologies, you can feel free to check out just our website, www.echowavepower.com. Or if you have any questions, feel free to send an email to info@echowavepower.com or to my personal email of yair@echowavepower.com. Thank you.
Thank you, Yair, for your presentation, and very interesting one, and to see that there is progress in the commercialization of your technology. Please stay with us for the Q&A at the end. So we have to continue now with our presenters. We are a little bit behind our schedule. So we go to Mr. Matija Vajdic from the Energy Institute Hrvoje Požar for the funding opportunities for the implementation of blue energy technology. The presentation will be given in Croatian. So again, I invite the online listeners to switch to the English channel. And also, once again, I kindly invite the online listeners to fill in the questionnaire. So, Matija, please start with your presentation.
So, thank you, Hrvoje, for the introduction. Can you hear me well?
We can hear you very well.
2 days ago, I had some problems, but now I fixed everything, so it should be fine. Before I...
Na hrvatskom smo dogovorili.
In Croatian, I will switch to Croatian. I just wanted to say before I start, wow to all the presenters that presented, that did their presentations. It's really impressive what research and development does, and how these pilot projects are actually changing the whole world. So thank you for this interesting presentation. And now I switch back to Croatian.
So today's topic of this presentation is I'm going to present to the so-called financial mechanisms of European economic space in the Republic of Croatia. There are two financial mechanisms. One is related to EEC, and these are the countries of Iceland, Liechtenstein, and Norway. And the second financial mechanism is the Norwegian financial mechanism, just trying to speak in more general terms so that all of you know the exact overview of these various financial mechanisms. So these mechanisms in Croatia are available in the period from 2014 to 2021, plus additional 3 years needed for the implementation and completion of the project. We are in 2021, and please don't ask me why do we talk about this today, but we agreed that we will really invest all our efforts to launch the funds that we have available in EEC and to sort of use these funding in the most appropriate places in the final 3 years that we have at our disposal. So these countries that I mentioned, they basically they launch 2.8, practically almost 3 billion euro. And in this period, from 2014 to 2021, for Croatia, we had secured 103.4 million euro, of course, naturally with the co-financing of the Croatia, because we secured 9.8 million euro, because these topics are focused sometimes in the field of judiciary, education. Very recently we had a tender related to innovation published, and it was very interesting. So our program, that is actually the climatic changes. So this was like a wider introduction into the entire program or the entire financial mechanism. The programs are organized in the Republic of Croatia in a way that they are run by the Ministry of Regional Development and European funds. So they are in charge of the entire portfolio of projects, education, innovations, and also energy sector as well. Together with the controlling that is that everybody who works with these mechanisms is well acquainted with. So Ministry of Finance is also engaged for the revision for the audit of projects and for all the irregularities, and each of these programs within the portfolio has their own manager. And we from the Institute, we are partnering the Ministry of Regional Development. We are partnering with the Ministry because actually we are running this joint program. We are so-called programs partner. We are their program partner, and they are program operator. This is just to provide you with an image of stakeholders. So who are we as stakeholders? So what I also mentioned, we have 6 programs. Program number 3 is our program. It is energy and climatic changes. So we have some 20 million euros that we need to use. And with the stakeholders that are related to Croatia, we have our partner from Dover, who we intensely collaborate with. So they are like a government office that deals with the issues from energy sector, and we are in very intense communication with their office for international collaboration. So this was just like a very short presentation of the establishment of the organization of this program. So Hrvoje Požar Institute, we are a program partner and we are in charge of the technical aspect of this entire financial mechanism, and the ministry is in charge of financial administrative matters all related to that segment. So so what are we going to find through this program? So you have the list. First of all, we have the predefined project. I will just describe it in more detail in the end, because it is currently not that important. We will have 4 open calls and 2 smaller grant schemes. These open calls for project proposal, we will fund. This will be connected energy efficiency exclusively. Is this predefined project. Open calls we finance C, photovoltaic cells, photovoltaic power stations, geothermal sources. Very shortly I will say a few words about these C projects that we intend to finance. Maybe I should start from the end with the grant schemes. So we will announce these tenders by the end of the year. So one will be related to shallow geothermal energy sources and another one to deep geothermal energy sources. But basically we need to collect the database. So this funding, we would like to use this funding to create an open platform for shallow and deep geothermal sources users, so that this database will be institutionalized in a way. Currently it is institutionalized, especially if we talk about the deep geothermal sources, because now we know which agencies are a key stakeholder in this area, but also for shallow geothermal sources, we know how these data are collected. So basically our final objective would be to use these 2 grant schemes to present these databases as in the best possible way to potential users of these geothermal sources, to show what kind of potential exists in the country, to show some examples of good practice, and to kind of like stimulate this sector to more use of geothermal energy. Mostly is located currently in the Pannonia Basin. So Dalmatia is excluded because in Dalmatia there are no deep geothermal sources, but when we talk about the shallow ones, Dalmatia is also open. So these 4 open calls, let me start from the last one. It is technical documentation for geothermal energy sources. So this is the open call number 4. Maybe I can just this open call number 4, we are talking about technical documentation for geothermal energy sources. We need to publish it in June. I explained to you who all the stakeholders are and how complex all this is. Basically, the call is ready, but now we need to define all the other procedures. But I do hope that this will be this open call will be announced in the second quarter of the year. So by the end of June, the smallest grant is 200,000 euros, and the 200,000 euros, and the biggest amount of this grant scheme number 4 is 1,300,000 euros. But I do believe that mostly those who will submit their proposals, they will target this smaller amount of 200,000 euro. So the focus in this open call is on documentation, and very closely related is the open call number 3, who will happen a little bit later. We hope that we will be able to publish it in September. We have 9 million euros. These are concrete drillings, the concrete wells that will be financed. Now we are currently negotiating with the most ready stakeholders in Croatia. The second open call that we will publish in June, we have 7.4 million euros. So again, we have the same amounts in all those open calls. And this is the energy production from the photovoltaic power stations. We are talking now about the buildings. They can be public or private buildings, it doesn't matter. There will be, of course, difference in co-financing, but currently we are in the process of definition. We will finance private sector with 40% and 85% public sector. So the smallest amount of grant is about 200,000 euros. So we are talking 250 kilowatt projects, but of course we will allow the possibility to bundle together several facilities such as kindergarten, schools. In private sector, we can talk about the production capacities that could maybe use photovoltaic cells or shopping centers or something else. So the eligible costs will be photovoltaics, maybe the consoles, maybe the for then and cabling, of course. So this will also be defined in the call that will be announced. And because I need to say a little bit more about the sea energy, I will talk about it a little bit more in the last slide. We have 1.5 million euro for the open call number 1. This is, for example, and the predefined project. We will incorporate national training sectors for practically zero emission buildings. The Faculty of Civil Engineering is our partner in this program, and we believe that this center will be established here at Hrvoje Požar Institute. We still do not have 3D model of a new reconstructed building, but we will have the recycled facade, the integration of mobility in the building, charter, storage, geothermal. Of course, we will use the shallow geothermal energy systems and similar technologies. This is going to be very interesting. The implementation of the project lasts 3 years, and I hope that many of our participants today will be present or will participate in a training in this center. So we need Faculty of Civil Engineering because we will include a number of civil engineers, because we need to link together construction and energy efficiency immediately. So now I'm going back to what actually is the topic of this presentation. We are planning this open call for June, but maybe it can be July or August. We are talking about 1.5 million euro. This is just a paragraph that is actually a kind of like a paragraph that we focus on. So we will finance weather projects or research studies about or new installed capacities that are focused. So these are heaters, with a focus on heaters, and we will finance also partly, we will finance private and public sector. We will just finance all the best projects. These will be projects very similar to transnational cross-border collaboration projects. So you have to describe what you are going to do, when you are going to do so. We need to have project management, communication, focus will be also on dissemination of your good experiences. So, of course, the implementation as well. So, again, we talk the amount of the project financing will be from 200,000 to 1,300,000 euros. So we can finance only one big project, or we can finance several smaller projects. Although these amounts, unfortunately, we just inherited these amounts, and we really agreed to just announce this open call. So we'll just put focus on the project. So in the most developed stage, we will have evaluation of projects. This call will be open some 2 to 3 months. Probably they will be still open in September because of the holidays, holiday season. So we will award the most realistic projects in a way, and the criteria are already defined. We need to fine-tune them with our Norwegian partner, and they will be publicly known in the end of June, when we hope that this tender will be publicly announced. So this is a very short presentation of the program. If there are any questions, of course I will stay here with you, so you can also contact me via email, or you can just call me. I forgot to put my telephone number, but I will be glad to talk to you also on the phone. Thank you for listening, and we are really expecting some serious proposal submissions.
I hope that there will be questions later on, so please stay with us. We have to move on with our schedule and the agenda, so we are moving to our next presenter, Professor Maria Lopez Gallego from the University of Oviedo. So Mario is working as, I already said, a professor, but at the Department of Construction and Manufacturing Engineering. He is currently, he researches on sustainable marine structures and offshore renewable energy technology, being the coordinator of the Protos project. So Mario, are you with us?
Yes. Can you see my presentation? And hear me?
See you. Please share the screen, and so we can see the presentation.
Now?
Now we see your presentation. So thank you, and the floor is yours.
Okay, thank you. Okay, good morning to everyone, and thank you for attending this presentation on the Protos project. I hope you enjoy it. Well, first of all, I would like to thank the organizers of this Blue Deal Croatia Lab for their kind invitation to be here and participate of this event. I am very happy to share with you my experience with Protos project and the main purpose of this project. Well, let me introduce myself just for a couple of seconds. I'm Mario Lopez. As was said, I am professor at the Department of Construction and Manufacturing Engineering of the University of Oviedo in Asturias, northern region in Spain. I teach several courses on continuum mechanics and structural analysis at undergraduate and graduate levels, and I am also the leader of a small research team that we are building up at the university, in which we are working on two main topics. On the one hand, we are working on marine renewable energy, mainly wave energy converters and also floating photovoltaics. But we are also collaborating with companies, local and foreign companies in offshore wind projects and also tidal stream energy projects. And on the other hand, we are also developing novel and sustainable marine structures such as floating breakwaters and aquaculture facilities, among others. Currently, Portos is our main project in which we are involved since the beginning of 2019. And so, what is Portos project about? Let's go with a short intro to the project. As we are late, I will try to be brief. So let's start with this. Okay, as it is well known, seaports, or just ports, are a tool for economic and social development. A high-quality port infrastructure has a positive effect on economy at regional, national, and international scales. In fact, efficient logistics services are today truly important to develop nations. Don't forget that the relevance of maritime transport, more than 85% of world cargo traffic is transported through sea, and consequently, of course, through seaports. For instance, in Spain, where I come from, more than 50% of export and 80% of imports are made by sea. On another note, ports play a relevant social role, especially for their local communities. Today, it's quite common that ports support different events and projects through sponsorship with the final purpose of attracting social support. But there are also other indirect social contributions that benefit local communities. For example, ports usually invest in training and educational programs. As the Port Authority of Douro in Porto, Portugal, which is one of our partners. In these pictures, you can see the cruise terminal of the port, designed by the architect Pedro Silva, which now houses a research center for marine science and engineering of the University of Porto, which is also one of our partners in the Portos project. At the same time, the energy demand of international shipping is really high, as you well know, and it includes seaports. During the last decade, the energy demand of the world port system has increased by almost 2% per year on average. Remember that energy cost can be significant overhead for ports, and the reduction brings valuable cost reductions. To reduce this energy consumption, the operational efficiency of resources must be increased to enhance the energy efficiency of ports. Despite alternative fuels, for example, biodiesel or hydrogen, well known, are gaining popularity over fossil fuels as energy source. The use of electricity from renewable energy is a promising alternative, of course. In fact, in the recent years, there has been a shift towards electrification, not only of equipment, but also by replacing fuel to supply power for ships during throttling at berth. Of course, this high energy demand also results in high emissions of both pollutants and greenhouse gas, which should be reduced for contributing to the sustainability and green perspective of ports. It is quite interesting, at least to me, that although there exists a public awareness of the effect of land transport on the environment and the measures to reduce them, there is a general lack of knowledge in society about the impacts of shipping on the environment. As I said before, at least it is curious. But nowadays, many port policymakers and port communities, especially those close to cities, have started climate-friendly strategies for reducing these greenhouse gas emissions in port waters, yards, and hinterland. This emission reduction is a direct consequence of this objective of energy efficiency, electrification, and the use of renewable energy in ports that I mentioned before. And it constitutes a big part of the next generation port concept. Okay, regarding renewable energy in ports, we have good news because ports have vast amounts of renewable energy resource on site, and particularly marine renewable energy. We have started to harness offshore wind energy, and also solar photovoltaics are being deployed in many ports. However, there are other renewables that are still unexploited. I'm talking about wave energy, tidal energy, and offshore solar energy, which arise as a promising alternative. However, this marine renewable energy have failed to generate electricity, at least from a commercial perspective or in a commercial scale. There are a large list of failures of different companies in their aim to produce electricity from this kind of marine renewable energies. On another hand, in ports, we have infrastructures on site that can help to deploy and reduce costs of marine renewable energy. This includes many different facilities and services, for example, shipyards, electric installations, and connection points to the electricity grid, among others. In fact, we have already some examples of renewable energy in ports, such as this wind turbines installed in a breakwater in a port of Spain, in Bilbao, and there are many other examples. Oh, sorry. Well, this was the motivation behind Portus project, to exploit this convergence of resources, demand, and facilities in ports. A few years ago, I was working on a new wave energy conversion system at the Faculty of Engineering of the University of Porto. With my colleagues, we started to think about this. If there are many projects on wave energy failing, you can remember maybe the Pelamis concept that was being developed by a Scottish company, and there was a demonstrator in northern Portugal, and it failed, and as well as other projects, similar projects to Pelamis. And we started to think, if we cannot generate electricity in ports and for ports, then we cannot move to a commercial exploitation of this kind of marine renewable energies. And so let's start with ports. Well, and Portus project started with that idea, with the aim of assessing, developing, and promoting renewable energy in Atlantic area ports, with this purpose of increasing the energy efficiency. Financed by Interreg Atlantic Area Program, the project involved 12 different partners from different countries. There are 5 universities: University of Porto in Portugal, University of Santiago de Compostela, and University of Oviedo, where I come from, in Spain, EIGSI, School of Engineering in France. There are also 3 research and development centers, IH Cantabria in Spain as well, my center of the University College Sport in Ireland, and INEGI from Portugal. We have also a company, INC, from France, which is focused on marine renewable energy development. And finally, and more importantly, we have 3 port authorities from Shannon Point in Ireland, from Porto in Portugal, and from Vigo in Spain. But what are we doing? Let me show you just a few examples. We have no time. What we are doing first is connecting academia with society, regarding research on marine renewable energy, implementation of this technology in ports, and so on. We are hosting 3 different types of events. We have thematic seminars with stakeholders, similar to this one today. It's directed mainly to local companies, policymakers, and port authorities to inform not only about the Portus project results, but also about the advances in the field of marine renewable energy. Then we also have open labs and open ports. First are directed to students to promote engineering and science on these topics related to Portos project, and to show the facilities, the research laboratories we have at the universities and what we are doing, because sometimes our students they don't know what are we doing in terms of research. And then open ports are organized by the ports in the partnership to show local communities the plans for marine renewable energy and efficiency in their installations. More technical actions. We have conducted marine renewable energy assessments. Here, it's just an example of the Port of Vigo. We carried out the analysis at the University of Oviedo. We are assessing the resource of wind energy, wave energy, tidal energy, solar energy in the port and its hinterland. Sorry. But not only the resource assessment, we are also analyzing the restrictions to marine renewable energy projects in the port to finally define the available areas for its renewable energy. What else? We are also optimizing technology for ports after the resource assessment analysis, having defined the best areas for each renewal. What we are doing is optimizing this technology. For instance, in this case, for the Shannon estuary in Ireland, after the resource assessment, we were testing in the wave current flume of the University of Santiago different models of steam energy converters, or what is the same of tidal turbines. In this picture, a vertical axis turbine, a Gorlov one. And after the experiment, we were testing the technology through simulations, through computational fluid dynamics, but for the specific conditions of each port, not in a general way. More examples of what we are doing. We are carrying out the proof of concept of emerging technology. We have an open call for local companies in the areas of the Atlantic area. They have sometimes ideas about novel technologies that can be used to harness the marine renewable energy resource in ports. And this is one of the examples. There is a company in Asturias, Spain, that they are solar panels or solar structures manufacturers, and they had an idea about a kind of TLP, tension left platform, on which is a solar tracker is mounted. And what they wanted is to check or to validate this technology, a proof of concept, but they didn't know how to do this, or they don't have the know-how for this. They come to the University of Oviedo, and we were doing simulations of the behavior of this structure under waves, wind, and currents, and we are now drawing the conclusions of this analysis. But there are many other examples. For instance, in the University of Porto, they were testing a new wave energy converter for a company in France, I guess, and the same in the IH Cantabria. They were also testing in the wave tank wave energy converter. I guess that there is also a new floating photovoltaic system that is being tested in another wave tank, maybe in Marais, in Ireland. And now the call is still open for companies of the Atlantic area to come and ask us for help in testing or validating their devices. To me, it's one of the most interesting parts of the project, because we can give support from the research centers and universities to local companies that maybe sometimes small companies and don't have the know-how for going through this kind of experiences. Okay, what is our final purpose? Well, next year, what we will try is to define energy self-sufficiency action plans for target ports is Porto, Shannon, and Vigo Port, and then develop a decision support tool to deploy marine renewable energy in other ports, not only of the Atlantic area, but worldwide. After the action plans for our target ports, we will apply the same methodology to other ports in the Atlantic area, a port from Cornwall in the UK, and the port of Nantes in France. What we would like to develop is this tool that could be applied for other ports worldwide. This tool will be able to identify for each port, and with the required data, of course, the renewable energy resource, the locations for the exploitation in and around the port, and the most appropriate technology to be used in each port. On this basis, roadmaps for transition towards energy mix diversification and achieving self-sufficiency will be defined for each target port. And that's all. If you want, you can visit our website, www.portosproject.eu, or you can send me an email to mario.lopez@uniovi.es. That's all for now. Thank you very much. I hope you enjoyed the presentation. At least you got an overview of the project and what we are doing. So thank you very much again.
Thank you, Mario, for your presentation and the overview of the activities in the Protos project. We continue with the different project presentations. So we are going to the Interreg Italy-Croatia Coast Energy Project presentation, which will be presented by Mr. Vladimir Vidovic. He is working for the International Center for Sustainable Development of Energy, Water and Environment Systems. So, Vladimir.
Thank you, Hrvoje. I will present the Coast Energy Project. So the Coast Energy Project is funded by the Interreg Italy-Croatia as a part of Blue Innovation Priority Axis. And the main goals of this axis are enhancing the business investment in research and development sector, to involve the high educational centers like universities, to promote technology transfers between stakeholders and countries, and to develop needed framework for investment into this technology of blue energy. The Coast Energy Project is here with the main goal to enhance the framework conditions to promote innovation in the sector of blue energy and to promote investment in that sector. Also to develop the knowledge of the blue energy potential and to share it among our stakeholders in Italy and Croatia, and further, of course, to create coast energy networks, hubs, also local hubs in each target area, and cross-border hub between Italy and Croatia. All the partners need to prepare and develop feasibility studies in their targeted areas. And here on the right is the list of all the partners, with the lead partner IRENA, which is Istrian Regional Energy Agency. Next slide, please. First, here on the right picture is our area, which is Lošinj-Cres Archipelago. And with the two cities, which are Cres and Mali Lošinj. For this area, we prepared blue energy potential analysis. And first, we made preliminary overview of the most suitable technologies, which will be presented in the next slide. Then into identified all the areas for pilot projects and feasibility studies. Very importantly, to make an overview of all regulatory acts from international and EU level to the national level and local level. And I would say that regulatory acts on national level are the most important for implementation of these projects. to analyze existing cases and all the references from other projects and best practices. Next slide, please. For the technology assessment, first we analyze the wave power, but for our area in the Northern Adriatic Sea, we have to say that the potential is not significant, so we didn't make feasibility studies for this technology. The similar is for the tidal power. For the offshore wind power generation, there are significant potentials, but we are aiming for the technologies near the shore for the areas in the ports and urban areas on the coast. So lastly, the technology that shows the best potential for us is definitely thermal energy, which can be implemented by the seawater heat pumps. On the right picture, there are first the working principle during the summer when we need cooling and we are throwing out the heat from the buildings into the sea. And in the winter, when we need heating, we are extracting the heat from the sea. The main things about seawater heat pumps are that one unit can be here for both heating and cooling, so you don't need two different systems. Probably the best thing is high efficiency, which is measured by coefficient of performance and is usually higher for seawater installations than air-to-air installations. One barrier can be that to get the best efficiency, the buildings need to have a low temperature heating. For the higher temperature heating, it can be implemented, but the efficiency drops significantly. To get high efficiency from seawater, it can be done due to sea temperature that is always stable, and it is always between 11 and 25 degrees in our area, which is shown on the graph on the right. And with installing that, we can significantly reduce the need for fossil fuels and exclude them completely for heating and cooling in our area, and which is important because there are not many pipelines in the Mediterranean region and in islands in Croatia and Italy as well. Here on the right are the numbers for one heat pump. It is important to say that when you are going to installation of heat pumps, this is not all the cost that you will have. Much more costly is the part if you need drilling the wells to install the whole installation and to put the pipes onto the seabed if it's needed. On the left, there are numbers for fossil fuel consumption in public buildings in Cres and Lošinj archipelago. And we can see that only them that are using fossil fuels are emitting more than 200 tons yearly of CO2. Sorry if I skip. So there are two types of seawater heat pumps based on the water intake. On the left, there is direct intake, which takes the water directly from the sea. And for that, you need to put the water intake pipes onto the seabed. There are some barriers that, in this case, you need to get a concession that is still not really well defined with the national government, with county officials and similar. And another barrier is that you need to clean those pipes more or less every year, depending on the location. Also, this is open loop installation. Also, you can have a closed loop where there is heat exchanger directly put onto the seabed. On the right, there is an indirect intake. For this, you have a problem that you need to drill the well, which presents additional cost, but with that, you don't need to clean the pipes that often, and you have skipped a really important step, which is asking for concession. You only need to get a permit from water management body, which is the case in Croatia, but it is similar in many other countries. After that, we made short feasibility studies. We made them before organizing first meeting of our local hub. We analyzed only buildings that use fossil fuels. We didn't analyze the buildings that have electric heating, since they are quite more efficient. And we use data from the ISGE, the National System on Information about Buildings. We didn't consider cooling, since most of the buildings we analyzed didn't have cooling systems. 3 buildings that we analyzed were first elementary school in Sres that uses heating oil, then educational home in Mali Lošinj and retirement home in Sres, and they are using LPG. On the right picture, there is cash flow analysis for retirement home in Sres. And we can see that we are starting to make profit from the investment in the 6th or 7th year, and it depends on the efficiency of the system. Also, these numbers are even better if we consider that costs are significantly lower when we start to plan the building from the scratch. Local hub. For us, it was important to invite and include all important stakeholders from public authorities, research bodies, NGOs, small and medium enterprises, business support organizations, and especially organizations like Energy Agency that have data and information about energy consumption. In our case, we got great support from local development agency, OTRA, Island Development Agency. It was also important to invite harbors masters, since they are always included when you want to install something onto the seabed into the areas where you have ports. First meeting was organized last year in September. Also, we shared many information about feasibility, since we wanted to inform potential investors that they should use seawater heat pumps and what are the benefits. For example, we had one institute called Blue World that is planning to build a new building, and for them heat consumption will be really important, since they will have pools that will be heated. And in the end, we got really good insight for the situation on the local level, and we got their idea to create feasibility study for Town Hall of Mali Lošinj, which is an older building. And for them, we started planning to develop the whole project for the building. So Town Hall Mali Lošinj on the picture. It is a really old building from 1890, and it is under architectural conservation, which presents some problem in some cases, but for the installation of seawater heat pumps, not so much. It uses heating oil for heating, and it has a 400 kilowatt boiler in the basement. And for cooling, they have air-to-air heat pumps in the attic, which have capacity of 23 kilowatts, which is really undercapacitated for this building, and they are not meeting all the demand in the summer. So for this case, we would install a new seawater heat pump that would use less energy, that would emit much less emissions, and that would cover all the needs for both heating and cooling. Here are the numbers that from 2010 and 2011, where we can see that they emitted more CO2 for heating than the all electricity consumption in the building. Here is the location of the town hall. You can see it is just by the sea. So we could have chose the idea of direct water intake, but we would have to have we will have a construction works on the promenade, which is under conservation. So we decided for the indirect water intake and drilling the well that will be probably drilled on the place where the red dot is. We are planning to get financing from either national funds for energy efficiency or European funds. To give an idea what framework is needed in this case, what is necessary for others that are planning to build in this way, definitely you need to get either a construction permit for the building or to have a certificate that the building is older than 1968, like this one, and to get a certificate from electricity supplier. We hope when we finish this project, it is going to be a great example about dealing with all the framework and barriers that you can get to. And we also got a great help from Sea Adrian experiences. So for the whole archipelago, there are great potentials. At this point, there is big solar plant Orlets that is being built that will have 6.5 megawatts of capacity. And in Zulaya project on island Unie, where they have built desalination plant and battery system. This year there was founded the Energy Cooperation Absirtides that wants to further enhance the energy transition on the archipelago. For us with seawater heat pumps, we wanted to show how much emissions can we reduce if we replaced all the heating systems that use fossil fuels with seawater heat pumps. And in that case, all the emissions would be reduced by 24%. On the right image, there is, with the blue, is current situation in public buildings and residential buildings with fossil fuels, and how much less emissions we would have with seawater heat pumps. So also international hub between Italy and Croatia. The goal is to create the common roadmap for development of blue energy systems in Italian and Croatian coast. On the right is the picture of our first meeting and the only live meeting. We had one more meeting, sadly it had to be online, and the next week we are going to have the third one, again online due to coronavirus. The goal of this is also to share the knowledges and best practices in all our areas and to implement them in both countries. Also to widen the network and to connect all the stakeholders included in the project. And in the future, we would like to all the stakeholders from outside of the area to involve in the work of the project. So thank you. That would be all from me.
Thank you, Vladimir, for your presentation. We are going to the next presenter, Mr. Nikola Matak from the same organization. He will talk about the Interreg Italy-Croatia joint SECAP projects on the development of joint sustainable energy and climate action plans. So, Nikola, the floor is yours.
Okay, thank you, Hrvoje, for the introduction. Okay, I can start. So my presentation will be about the joint SECAP project, which is dealing with the development of joint sustainable energy and climate action plans. Just a few data about the project. The project started at the beginning of 2019, and it's funded from the Interreg program Italy-Croatia. It will end next month. And we are basically finished with all the project activities, having just a couple of more conferences and final conferences, which will be next month to do. The program area covers the Adriatic coast of Italy and Croatia, and maybe just to point out what's interesting about that, the English is the official language of the program, even though only Italy and Croatia partners participate in it. Population covering the area is also interesting that almost 90% is in Italy. So there were 4 program priority areas, and joint SECAP is in the second one, called Safety and Resilience. It got funded from 50 projects funded in the call, of which 10 from the Safety and Resilience axis. The lead partner is University of Camerino, and in the structure there is an equal number of Italian and Croatian partners. The main topic is climate change adaptation, and basically the focus is on adding the climate dimension or the climate change adaptation strategy to the existing sustainable energy action plans. This happened because mayors adapt the initiative which was launched by European Commission, got connected with the Covenant of Mayors initiative, and the strategy is that action plans dealing with energy are now dealing with both climate and energy. The project methodology actually is based on collaboration between local, regional, and transnational approach, because both Italian and Croatian territories are dealing with scattered and small-sized municipalities, which through multi-level governance approach need to be brought together so that they or for them it's easier to implement the goals. So idea is that to adopt this supra-municipal approach by joint SECAP, and with that to improve the performance of measures which are developed as a part of the Covenant of Mayors developing of sustainable energy and climate action plans. Also, the idea is to promote the strategies and instruments developed through the project to support the public authority. The first specific project objective is to create a platform for sharing data, knowledge, and good practices for joint actions on climate change adaptation. The second specific project objective is to promote the figure of joint action coordinator, who will be the main figure in development of joint SECAPs for each of the target areas, and using the platform to collaborate between different areas to develop the joint SECAPs. On the link here presented, you can see and visit the platform, which is full of the best practices, strategies, methodologies on how to develop both joint SECAPs and how to add the adaptation actions in the existing plans. And also soon on the platform you will be able to see the 8 joint SECAPs developed for the target areas. How did the process of the development of joint SECAP go through our project? Firstly, after the climate risk and vulnerability analysis, there were organized focus groups. The focus groups were basically workshops in which specific stakeholders discuss part of the measures that they were interested in. So, for instance, mitigation measures in buildings or adaptation measures for heat waves or some other hazard, just to get more details from the local stakeholders on their view on what should be the focus of the SECAPs. So also what was discussed is the joint SECAP and which approach should be used. So most of the areas opted for the joint SECAP option 2, which has joint goals for all municipalities. This helps them to easily implement larger actions, and since we are talking about small municipalities, they usually lack in funding sources and in staff. So in this way they can more easily reach the goals. The idea was to present them the possible measures. One of the measures we presented were, for instance, public lighting, and also the more complicated integrated measures on how to combine both mitigation and adaptation measures as one holistic approach for a certain area. Also, there were examples of just adaptation measures which could be implemented in urban areas, and the effect that they have on certain hazards present, and also the measures which can be implemented in rural areas as well. The second step after the initial draft was developing of scoping report for sustainable environmental assessment, which was a new step which hasn't been developed for SECAB yet. And the idea was that through this process to identify some shortcomings and gaps in the SEAP development, to see the compliance of the plan with other relevant strategies, and to further improve it in the process. Also, it was the methodology for sustainable environmental assessment was developed and shown how the methodology should work if the municipalities decide to do the full analysis for their area. And in the end, the mitigation measures and adaptation measures were adapted, and in total, the reduction of CO2 emissions reached, for instance, for our target area is around 56% by 2030. Here you can see some of the adaptation measures and the analysis done in one of the previous projects. You can see the hazards of urban heat waves, sea flooding, and so on. Okay, thank you. This is from me. I try to be as short as possible as requested by the organizers. For any questions, I'm still here. Thanks.
Thank you, Nicola. Being short is appreciated since we are a little bit behind the schedule. So we are moving to our next two presenters that will share their time slot. One is Daniele Groppi from the University of Sapienza, Rome, and he will be physically here with us, and a colleague from the University of Zagreb, Anton Pfeiffer, who is online. So Daniele, please.
Thank you, Ervoglio, for the introduction. As you said, I'm Daniele Groppi from Sapienza University, the lead partner of the PRISMI Plus project, a project financed by the Interreg Med program that started just a couple of months ago and will last until June 2022 with 7 partners covering 4 countries: Italy, Croatia, Bosnia and Herzegovina, and Greece, and also 8 associated partners that cover also Spain and France. So here a look at the consortium. As you may have understood by the name, the PRISMI Plus project is a capitalization project of PRISMI. So here we can see that the partnership is divided in giver partners and receiver partners. So the giver were partners of the original project, PRISMI, while the receiver partners are new in this project. And the role of the giver will be to transfer the knowledge to the receiver and also apply the toolkit in the receiver territories. There will be 4 case studies. It will be Ventotene Island in Italy, Mrkopalj in Croatia, Nisiros, another island in Greece, and the city of Čapljina in Bosnia and Herzegovina. So since PRISMI Plus wants to transfer the knowledge, here is some information about PRISMI, so the toolkit and the methodology that we are going to transfer and to apply. PRISMI wanted to develop a methodology and the toolkit to support small islands for their energy transition towards a clean and safe energy system. To do that, we developed this toolkit that enables the islands to plan this transition by analyzing the risk potential, but also the local community needs and respecting, of course, the territorial characteristics and regulations. And to do that, we had to follow 2 important keywords that were user-friendliness and free of charge. We wanted the toolkit to be easy to use, easy to understand the results, and of course, free of charge so that more municipalities and territories could apply it. And here are the objectives of the PRISMI Plus project. So the transferring of knowledge, as I said, from givers to receivers. This will be done through different means, training sessions, both online and also in person with B2B meetings, and with the development of guidelines in national languages. They're already available in English on the website, and soon they will be also uploaded in Italian, Croatian, Bosnian, and Greek. And the same goes for the training session. The other objective is the adjustment of the toolkit, because, as I said before, PRISME was tailored to small islands, but now 2 of the case studies will be rural areas, so some adjustments will be made. And the application of this of the toolkit on the case studies that will lead to the development of 2 sustainable energy and climate action plans for the rural areas and 2 clean energy transition agendas for the islands. We decided for the clean energy transition agenda since they are currently used by the Clean Energy for EU Island Secretariat. Here, just to look, since the project has just started, here we will look at some of the output of PRISME, and but this will be also the methodology and the toolkit that will be applied in this project. So this is the methodology that, as I said, followed the whole procedures for energy planning. So from the assessing of potential and the acquisition of data, both for renewables, but also for the consumption, to the processing of this data, so that we could use them for the simulation and the analysis of different scenarios to identify the optimal solution and the optimal energy mix for the island. This optimal energy mix that then would be tested for the feasibility, the technical feasibility of the power grid, and then would be translated into a strategic document and a political document. So here are all the steps that I just said, and for each step, guidelines were made to help the user for the energy plan process, and also different tools were developed. So, for instance, for the RES potential, we use GIS database, but for hourly data, we developed the wind power calculator, able to provide the hourly profile of wind speed and wind power production. For the energy scenarios, we analyzed 3 different scenarios with increasing RES penetration and also increasing electrification of demands. Then we developed a post-processing tool for an easy visualization of the results and understanding of the results. Then we'll see just a few pictures of all of this. And also important, the load flow tool developed within the project to assess the feasibility of the scenarios analyzed on the grid, on the power grid, and the development of sustainable energy and climate action plans, as I said before. So here just some images from the previous project. This is the Italian case study, Favignana in Sicily, the GIS maps for solar and wave potential. This is the wind power calculator that uses a database from the NASA and covers the whole Mediterranean. This is energy plan. We decided to use energy plan for the analysis of scenarios because, as I said, it fits one of the keywords, so it's free of charge. And also more important because it enables us to consider different energy consuming sectors, like heating and transport especially. And so it gives us the possibility to actually analyze the potential and the opportunities of sector coupling solutions. This is an image of the load flow tool. As you see, the user friendliness was very important for us, both for the user interface on the left, but also for the results on the right, where you have a topography of the grid. And if there is a fault is detected, it's colored in red, so it's immediate to visualize the problem if there is any. And here the post-processing tool. So the role of this post-processing tool is just to visualize the results and understand them. So here is just for the demand average. Because of the electrification of demand, the electricity demand would rise, of course. You could see the generation from different technology, there is share electricity, the carbon avoidance cost, or also some other more technical results in hourly profile. So thank you very much. I would just like to pinpoint that I put here the link to the website. So in case you're interested, you should go to see. We will upload soon the video for the training sessions and also the guidelines in the different languages. So stay tuned and thanks again.
Thank you, Daniele, for your presentation. Before we go further on with the last presenter, I would just kindly ask the online listeners to make the online evaluation questionnaire. So we up to now have only 8 responses. So please, there are a lot of you that can. It's quite quick to do it. So please do it. We are going to our last presenter, Mr. Anton Pfeiffer from University of Zagreb. He will talk about the EUCI project ACTA. So, Anton, please.
Thank you very much, Hrvoje. As Hrvoje kindly announced me, I will try to be short yet informative. I would like to present to you the Alpe Adria Clean Transport Alliance. I hope that everyone can hear me. So Alpe Adria Clean Transport Alliance is a project that is funded by EUCI, and as we already know now in the third day of this very interesting lab, there's a lot of potential in coastal areas to use the blue energy, but it is also important to use the energy in a sustainable way, and that especially is true for the transport sector. For example, for road transport, we can use renewable energy to decarbonize our transport sector. And this was one of our leading ideas when imagining this project. So who we are? We are a partnership of institutions from Austria, Slovenia, Croatia, and Montenegro. So Energy Agency from Styria, Research Development Center Koper, SDEVES Center, the lead partner from Zagreb, Croatia, and University of Montenegro, Faculty of Mechanical Engineering. What is the goal of this project? The goal of the project is to support local and regional governments. For example, our supporters from Split-Dalmatia County and Primorje Gorski Kotar County, whose support is greatly appreciated in this project. We want to support them and also the smaller municipalities which don't have large human capacities or a lot of knowledge and time to create measures and to create strategic documents that would support decarbonization of road transport. In this project, we are trying to gather them together with the academia, industry, and civil society to create a network, the Clean Transport Alliance, that will support each of the members in establishing policies oriented towards decarbonization of road transport in their communities. Also, we will share the knowledge and we will try to build capacity for our target groups in order to help them understand the role of decarbonization of transport in energy transition. So far, we managed to implement the work package 1, which was the benchmarking of road transport decarbonization, and we created some white papers for each of our countries, which you can find and read on the project website, which I will show to you soon. And now we are starting the conceptualization of the toolbox that will be custom-made to help and support local and regional government units in creating new strategic documents and measures to support road transport decarbonization. Already we implemented several events. One of them was dedicated to our stakeholders in Split-Dalmatia County, a county where we invited our partners to share their experiences and cases from Austria and Slovenia and Montenegro. We were discussing the situation in decarbonization of transport in Croatia, and what was very important for us, we were collecting feedback regarding the needs about what kind of tools would be helpful for local communities in order to create quality measures. All the materials that we presented on this event can be found on the project website, which is stated here, so sdeves.org/aacta, and also on YouTube channel of the SDEVES Center. As you can see, we went through all the current situation in our participating countries, and we managed to collect very useful feedback. Second event was organized also online, like the first one, in the February 15th of this year, and we had a researchers panel and we had economy and civil society panel to discuss the situation and potentials of decarbonization of road transport, and also the very important role of decarbonization of transport in systems with higher integration of renewable energy sources like blue energy sources. And after we got acquainted better with the science behind it, we went towards the civil society and our partners in the local and regional self-governments to hear their experiences, what they are doing currently on this topic, and also what they need from us in order to help them to make quality measures that will have meaningful impact. We created white papers for each country, which reflect the current situation of barriers for the decarbonization of road transport and needs of our users. These documents are, of course, live. They are awaiting any kind of comments from all of you that are listening, and they will be the starting point for our toolbox. So I hope that this was sufficiently short but yet informative, and we are always open for your comments and messages, so please contact us in case we can help also you, and maybe you want to join our Clean Transport Alliance. Thank you very much.
Thank you, Anton, and thank you for making it short and comprehensive. So we are only 9 minutes behind the schedule now. So, okay, just before starting with the Q&A session, I would just like to make an overview of what was presented today. So, first, Carmen presented the open innovation challenges. At the moment, there are 8 challenges that are prepared, from those where technical solutions are required to those which more focus on soft skills training. There was a student presentation. The goal was to meet the past and future demands, to be precisely, implementation of blue energy technologies to increase and protect the archaeological sites. Mr. Buzov, the main roadmap is to increase the usage of renewable energy sources, especially those that are already on commercial scale. Mr. Vicic, work is focused on design of power transmission and distribution system with the worldwide experience. At the moment, they are installing the wind turbine of 8 megawatts nominal capacity. The substations are often built at the shipyard due to harsh conditions at the sea. Mr. Uršić, that has a lot of questions waiting. Continuous increase in installation of new capacity for offshore wind with the European countries leading the process. The forecast after 2022 for the 10 megawatt capacity turbines, and after 2025 are 14 megawatts will be mostly installed for offshore installations. So I would just like to highlight that yesterday what we were discussing and what our energy planning for the Croatia and the Svi-Dalmatia case, we were very conservative. We were estimating for 2030 6 megawatts. So and here Mr. Uršić is suggesting that it should be more than double. Yair said about the wave energy is facing challenges with scaling up the project on commercial scale. EcoWave Power has 17 patents in the technology with a decade experience in testing. In Gibraltar, the testing plant has an average load factor of 30%. Matja Vajdic, the Norwegian grants offer great opportunities for project financing through national government bodies for different projects, also concerning the seawater heat pump installations. Mario Lopez Gallego presented the Protos project about the marine renewable energy in ports for the case for the Atlantic area. Mr. Vidovic for the Italy-Croatia Interreg project Coast Energy, which aims to promote the deployment of the blue energy technologies in this region. And at the end, we had Mr. Matak, who presented the joint SECA project that aims to develop, assess, and implement the measures for climate change adaptation. The special focus are on the areas that are especially sensitive and vulnerable to these changes. Daniele Groppi presented the PRISMI Plus project that is just starting, and it is a capitalization of the PRISMI project. The aim of the project is to ensure the knowledge transfer for the toolkit that was developed in the previous project. And at the end, Mr. Pfeiffer presented the EU key project ACTA that aims to support regional government for the decarbonization of the road transport. Hope I was brief enough. So to start with the questions, first of all, I would like to share also the information that this lab made it to the national newspapers, to the national television, and to the national radio. So this is a topic that was highly media covered, and we did several interviews, and it was really nice that it was followed significantly. So I start now with the online questions in the way they were coming. So just a moment. So first from Rodrigo Lorca to Mr. Uršičić. Mr. Uršičić, be prepared. You have a lot of questions.
Yeah, I'm ready.
Okay. Is it worth in the floating wind farm to use large jacket for the substation, or is it expected to use floated structure? So is it expected to use floated structures?
Yeah, actually, that is a very interesting question. I think it is not a problem to use jackets. For example, in some locations in oil and gas, they use jackets in, 300 meters and similar. And I think that, it can be done by a jacket, and it could be done by a floating. It depends, because if there is some area in this wind farm that is like a shallower water, maybe 100 meters, then for sure put a jacket there. But if it is whole floating wind farm very deep, maybe 400 meters, then jacket will be probably very, very expensive. In the end, it will be question of cost.
Okay, thank you for answering. We move to the next question. The next question is from Riccardo Polselli to Mr. Yair Rurik. Based on your experience and the monitoring that you have shown, what is an average interval of production in megawatt hours per year per one floater or per 1 meter pier in any Mediterranean context?
Yes, so it's a difficult question to answer because it's very much dependent on a few factors. First of all, I didn't go so much deep into this in my presentation, but we have used different floater sizes, which means that the generation is different in different locations. And we pick the floater size based on the wave climate, so average wave height and period at specific location. So it varies significantly, but let's say we take the case of the Gibraltar project, we use the floaters there of about 2.8 meter width, 3.6 meter length. And in that project, in our Jaffa project, so let's say 8 floaters in Gibraltar, that's 100 kilowatt installed capacity. And in our new Jaffa projects, it's 10 floaters, for 100 kilowatts installed capacity. So that gives you a bit of a perspective. But of course, like for other locations, let's say the project I mentioned in Portugal, we're developing. So there we can actually use a much lower amount of larger floaters to generate more. So therefore, about a 1 megawatt project will need like 40 floaters, which is 40% less than the Jaffa Port project. So it really varies.
Okay, thank you for answering. We move now to the next question, again from Rodrigo Lorca. It is addressed to Mr. Matija Vajdic. So are the different funding calls for geothermal and PV energy in sea or inland? So for the location, is it for onshore and offshore and islands and etc.? So Matija, please.
Thank you for your question. The geothermal is mostly focused, these grants related to documentation and actual drilling is focused on this Pannonian Basin, so it's a continental part of Croatia. For the 2 small grant schemes, they should cover the whole Croatia, which meaning this databases for shallow and deep geothermal. Solar covers also, the call will cover the whole Croatia, and I think that was the answer to your question.
Okay, thank you for answering. So we go back to Mr. Uršičić. Question from Matteo Macanti. What is the estimated lifetime of a floating wind turbine? Are there specific components that need to be replaced every few years during the lifetime of the turbine?
No, I think it is nothing specific for floating. The lifetime for a turbine design lifetime is, I think, 25 years or 20 years. It could be more or some, but as turbines are developing and growing, now after finishing of the lifetime, they are decommissioned, they are basically removed, and sometimes in the same location, the new better turbine is installed. But as floaters have no special moving parts, there should be no difference for floaters. The most critical is inside the nacelle, the generator, and all the mechanical parts that are moving.
My question connected to this, maybe the foundations are different because of the capacities or not?
Yeah, foundations are different. Of course, you have to remove foundations with a vessel and put you don't usually put foundations in exactly the same place. You just move it inside the limits of the wind farm. But everything is pulled out. Cables are pulled out. Foundations are pulled out. Substations is removed. Decommissioning is interesting topic for itself. But yes, it is. Everything is removed after 25 years.
Okay. Next question also addressed to you from Morena Bruno. What end-of-life scenarios can be assumed for an offshore wind system, meaning the recycling of steel components or landfill disposal for specific components?
Yeah, so all the metallic components are recycled. So the steel from foundations, the copper or aluminum from the cables, the tower, the nacelle, they are mostly metallic, and there are even some very valuable materials in the nacelle, in the generator, like rare earth metals. And the only thing that is not yet fully recycled is the blades. But as I understand, there are many industry initiatives how to make blades recyclable. Blades are made from fiberglass, and that is not easy even to cut and to destroy at the moment. But there are initiatives going on.
Okay, now a remark from the online for the online listeners. So it was a question. Could you please send us the evaluation questionnaire? Basically, it is available online. In the corner, you have the link for the evaluation, so you can use it parallelly to listening of this event. So please fill in the evaluation form. Now we don't have any more questions online or waiting for the question. Any different questions? presenters here? Do they have listeners here? Any questions here? No. So I will be waiting for few seconds for any other questions that might be online. I can only tell you that for these 3 days we really hit the spot with the information that we were giving first on the what opportunities and framework conditions on the first day, the second day with what are the specific energy planning for the Split Dalmatia County, and finally with this industry and project day. So as I see, we don't have any more questions. If there are any more questions, I would start with my questions to the Simone. Okay, just few questions. I have a question for the Carmen from CEI. It is regarding the Open Innovation Challenge. If you can say us a little bit, just shortly, how the solvers should approach and deliver their solution for the particular challenge.
Okay, thank you. Yes, there is a very easy way for them to respond to these challenges. They just have to answer through our platform, and through that, they can fill in a very easy document. They can put the information about the solution they are proposing, and with the information about the company, etc. And we will read it, and we will save it, and we will act with that to just to give them to the jury, and then they will be evaluated. So it is very easy. Through the same platform they have used to participate in this lab, they can submit their answers.
Okay, thank you for answering. We have Simone, our project coordinator, with us. I invite him to make his or question or final remarks on these 3 days. And Simone, please.
Yes, I mean, if you have finished with the questions there, I wanted just to make final remarks, I have to say. So if you, okay. We have learned something in these 3 days. We have confirmation that we are able to put together the expertise of the partner to provide very quickly a feasibility plan for the exploitment of blue energies in a certain area. I think we have proved again that we can do it as a partnership, and this is a very, very strong point for the partnership itself. Then we saw that there are several policy frameworks that are converging towards the implementation of blue energies, also in the Med area. So I think we are, in a sense, in the right spot at the right moment to show how to do it. Then this morning we have presented several very stimulating challenges, and I liked it a lot. This part, because they regard different aspects of blue energy implementation, and already this morning also the more technical presentation have shown that some of these challenges can be met, if not in the right now, in the very, very next future. So I'm really happy with the outcomes of this meeting, and we have only the regret that of the fact that we could not meet in person and so some of the exchanges that we could have had in person, and I mean questions and the interactions were not possible. But we hope that we can avoid this problem and tackle this problem by emails and online meetings, more online meetings. We thank you really, Hrvoje, your work, because you have done an incredible work during these days, and tomorrow I think there is another day with the schools. And so, with my compliments to all the organization, and the platform has worked beautifully. And so, thank you, thank all the participants and all the partners for these 3 days.
Thank you, Simone, for your kind words. I would just invite all of the presenters here to turn on their cameras so we can make a picture together, and all the physically here presenters, that we make it for our hybrid event that we had a nice picture. Okay, I hope that someone is making the print screen. I cannot do it on my own. Okay. Okay, thank you. And as a final remark, stay safe, get vaccinated so we can meet in person, and let's make a blue deal. Bye.
Thank you.
Bye, everybody. Thanks.
No, thanks.